Hi, good to see you. My name's Sally, and I'm here to teach you all about processing data. I'm a measurement and analytical lead at Google. My job is to help advertising agencies and companies measure success and analyze their data. So I get to meet with lots of different people to show them how data analysis helps with their advertising. Speaking of analysis, you did great earlier learning how to gather and organize data for analysis. It's definitely an important step in the data analysis process. So well done. Now let's talk about how to make sure that your organized data is complete and accurate. Clean data is the key to making sure your data has integrity before you analyze it. We'll show you how to make sure your data is clean and tidy. Cleaning and processing data is one part of the overall data analysis process. As a quick reminder, that process is ask, prepare, process, analyze, share, and act. Which means it's time for us to explore the process phase. And I'm here to guide you the whole way. I'm very familiar with where you are right now. I'd never heard of data analytics until I went through a program similar to this one. Once I started making progress, I realized how much I enjoyed data analytics and the doors it can open. And now I'm excited to help you open those same doors. One thing I've realized as I work for different companies is that clean data is important in every industry. For example, I learned early in my career to be on the lookout for duplicate data, a common problem that analysts come across when cleaning. I used to work for a company that had different types of subscriptions. In our dataset, each user would have a new row for each subscription type they bought, which meant users would show up more than once in my data. So if I had counted the number of users in a table without accounting for duplicates like this, I would have counted some users twice instead of once. As a result, my analysis would have been wrong, which would have led to problems in my reports and for the stakeholders relying on my analysis. Imagine if I told the CEO that we had twice as many customers as we actually did. That's why clean data is so important. So the first step in processing data is learning about data integrity. You'll find out what data integrity is and why it's important to maintain it throughout the data analysis process. Sometimes you might not even have the data that you need, so you'll have to create it yourself. This will help you learn how sample size and random sampling can save you time and effort. Testing data is another important step to take when processing data. We'll share some guidance on how to test data before your analysis officially begins. Just like you'd clean your clothes and your dishes in everyday life, analysts clean their data all the time too. The importance of clean data will definitely be a focus here. You'll learn data cleaning techniques for all scenarios, along with some pitfalls to watch out for as you clean. You'll explore data cleaning in both spreadsheets and databases, building on what you've already learned about spreadsheets. We'll talk more about SQL and how you can use it to clean data and do other useful things too. When analysts clean their data, they do a lot more than a spot check to make sure it was done correctly. You'll learn ways to verify and report your cleaning results. This includes documenting your cleaning process, which has lots of benefits that we'll explore. It's important to remember that processing data is just one of the tasks you'll complete as a data analyst. Actually, your skills with cleaning data might just end up being something you highlight in your resume when you start job hunting. Speaking of resumes, you'll be able to start thinking about how to build your own from the perspective of a data analyst. Once you're done here, you'll have a strong appreciation for clean data and how important it is in the data analysis process. So let's get started. Welcome back. In this video, we're going to discuss data integrity and some risks you might run into as a data analyst. A strong analysis depends on the integrity of the data. If the data you're using is compromised in any way, your analysis won't be as strong as it should be. Data integrity is the accuracy, completeness, consistency, and trustworthiness of data throughout its life cycle. That might sound like a lot of qualities for the data to live up to, but trust me, it's worth it to check for them all before proceeding with your analysis. Otherwise, your analysis could be wrong. Not because you did something wrong, but because the data you were working with was wrong to begin with. When data integrity is low, it can cause anything from the loss of a single pixel in an image to an incorrect medical decision. In some cases, one missing piece can make all of your data useless. Data integrity can be compromised in lots of different ways. There's a chance data can be compromised every time it's replicated, transferred, or manipulated in any way. Data replication is the process of storing data in multiple locations. If you're replicating data at different times in different places, there's a chance your data will be out of sync. This data lacks integrity because different people might not be using the same data for their findings, which can cause inconsistencies. There's also the issue of data transfer, which is the process of copying data from a storage device to memory, or from one computer to another. If your data transfer is interrupted, you might end up with an incomplete data set, which might not be useful for your needs. The data manipulation process involves changing the data to make it more organized and easier to read. Data manipulation is meant to make the data analysis process more efficient, but an error during the process can compromise that efficiency. Finally, data can also be compromised through human error, viruses, malware, hacking, and system failures, which can all lead to even more headaches. I'll stop there. That's enough potentially bad news to digest. Let's move on to some potentially good news. In a lot of companies, the data warehouse or data engineering team takes care of ensuring data integrity. Coming up, we'll learn about checking data integrity as a data analyst. But rest assured, someone else will usually have your back too. After you found out what kind of data you're working with, it's important to double-check that your data is complete and valid before analysis. This will help ensure that your analysis and eventual conclusions are accurate. Checking data integrity is a vital step in processing your data to get it ready for analysis, whether you or someone else at your company is doing it. Coming up, you'll learn even more about data integrity. See you soon. Hey there! It's good to remember to check for data integrity. It's also important to check that the data you use aligns with the business objective. This adds another layer to the maintenance of data integrity because the data you're using might have limitations that you'll need to deal with. The process of matching data to business objectives can actually be pretty straightforward. Here's a quick example. Let's say you're an analyst for a business that produces and sells auto parts. If you need to address a question about the revenue generated by the sale of a certain part, then you'd pull up the revenue table from the dataset. If the question is about customer reviews, then you'd pull up the reviews table to analyze the average ratings. But before digging into any analysis, you need to consider a few limitations that might affect it. If the data hasn't been cleaned properly, then you won't be able to use it yet. You would need to wait until a thorough cleaning has been done. Now, let's say you're trying to find how much an average customer spends, and you notice the same customer's data showing up in more than one row. This is called duplicate data. To fix this, you might need to change the format of the data, or you might need to change the way you calculate the average. Otherwise, it will seem like the data is for two different people, and you'll be stuck with misleading calculations. You might also realize there's not enough data to complete an accurate analysis. Maybe you only have a couple of months' worth of sales data. There's a slim chance you could wait for more data, but it's more likely that you'll have to change your process or find alternate sources of data while still meeting your objective. I like to think of a data set like a picture. Take this picture. What are we looking at? Unless you're an expert traveler or know the area, it may be hard to pick out from just these two images. Visually, it's very clear when we aren't seeing the whole picture. When you get the complete picture, you realize you're in London. With incomplete data, it's hard to see the whole picture to get a real sense of what is going on. We sometimes trust data because if it comes to us in rows and columns, it seems like everything we need is there if we just query it. But that's just not true. I remember a time when I found out I didn't have enough data and had to find a solution. I was working for an online retail company and was asked to figure out how to shorten customer purchase to delivery time. Faster delivery times usually lead to happier customers. When I checked the dataset, I found very limited tracking information. We were missing some pretty key details. So the data engineers and I created new processes to track additional information like the number of stops in a journey. Using this data, we reduced the time it took from purchase to delivery and saw an improvement in customer satisfaction. That felt pretty great. Learning how to deal with data issues while staying focused on the objective will help set you up for success in your career as a data analyst. And your path to success continues. Next up, you'll learn more about aligning data to objectives. Keep it up. Every analyst has been in a situation where there is insufficient data to help with their business objective. Considering how much data is generated every day, it may be hard to believe, but it's true. So let's discuss what you can do when you have insufficient data. We'll cover how to set limits for the scope of your analysis and what data you should include. At one point, I was a data analyst at a support center. Every day, we received customer questions which were logged in as support tickets. I was asked to forecast the number of support tickets coming in per month to figure out how many additional people we needed to hire. It was very important that we had sufficient data spanning back at least a couple years because I had to account for year-to-year and seasonal changes. If I just had the current year's data available, I wouldn't have known that a spike in January is common and has to do with people asking for refunds after the holidays. Because I had sufficient data, I was able to suggest we hire more people in January to prepare. Challenges are bound to come up. But the good news is that once you know your business objective, you'll be able to recognize whether you have enough data. And if you don't, you'll be able to deal with it before you start your analysis. Now let's check out some of those limitations you might come across and how you can handle different types of insufficient data. Say you're working in the tourism industry, and you need to find out which travel plans are searched most often. If you only use data from one booking site, you're limiting yourself to data from just one source. Other booking sites might show different trends that you would want to consider for your analysis. If a limitation like this impacts your analysis, you can stop and go back to your stakeholders to figure out a plan. If your dataset keeps updating, that means the data is still incoming and might not be complete. So if there's a brand new tourist attraction that you're analyzing interest and attendance for, there's probably not enough data for you to determine trends. For example, you might want to wait a month to gather data. Or you can check in with the stakeholders and ask about adjusting the objective. For example, you might analyze trends from week to week instead of month to month. You could also base your analysis on trends over the past 3 months and say, here's what attendance at the attraction for month 4 could look like. You might not have enough data to know if this number is too low or too high, but you would tell stakeholders that it's your best estimate based on the data that you currently have. On the other hand, your data could be older and no longer be relevant. Outdated data about customer satisfaction won't include the most recent responses. So you'd be relying on ratings for hotels or vacation rentals that might no longer be accurate. In this case, your best bet might be to find a new data set to work with. Data that's geographically limited could also be unreliable. If your company is global, you wouldn't want to use data limited to travel in just one country. You'd want a data set that includes all countries. So that's just a few of the most common limitations you'll come across, and some ways you can address them. You can identify trends with the available data, or wait for more data if time allows. You can talk with stakeholders and adjust your objective, or you can look for a new data set. The need to take these steps will depend on your role in your company, and possibly the needs of the wider industry. But learning how to deal with insufficient data is always a great way to set yourself up for success. Your data analyst powers are growing stronger, and just in time. After you learn more about limitations and solutions, you'll learn about statistical power, another fantastic tool for you to use. See you soon! Okay, so earlier we talked about having the right kind of data to meet your business objective, and the importance of having the right amount of data to make sure your analysis is as accurate as possible. You might remember that for data analysts, a population is all possible data values in a certain data set. If you're able to use 100% of a population in your analysis, that's great. But sometimes collecting information about an entire population just isn't possible. It's too time-consuming or expensive. For example, let's say a global organization wants to know more about pet owners who have cats. You're tasked with finding out which kinds of toys cat owners in Canada prefer. But there's millions of cat owners in Canada, so getting data from all of them would be a huge challenge. Fear not. Allow me to introduce you to sample size. When you use sample size, or sample, you use a part of a population that's representative of the population. The goal is to get enough information from a small group within a population to make predictions or conclusions about the whole population. The sample size helps ensure the degree to which you can be confident that your conclusions accurately represent the population. So for the data on cat owners, a sample size might contain data about hundreds or thousands of people, rather than millions. Using a sample for analysis is more cost-effective and takes less time. If done carefully and thoughtfully, you can get the same results using a sample size instead of trying to hunt down every single cat owner to find out their favorite cat toys. There is a potential downside, though. When you only use a small sample of a population, it can lead to uncertainty. You can't really be 100% sure that your statistics are a complete and accurate representation of the population. This leads to sampling bias, which we covered earlier in the program. Sampling bias is when a sample isn't representative of the population as a whole. This means some members of the population are being overrepresented or underrepresented. For example, if the survey used to collect data from cat owners only included people with smartphones, then cat owners who don't have a smartphone wouldn't be represented in the data. Using random sampling can help address some of those issues with sampling bias. Random sampling is a way of selecting a sample from a population so that every possible type of the sample has an equal chance of being chosen. Going back to our cat owners again. Using a random sample of cat owners means cat owners of every type have an equal chance of being chosen. So cat owners who live in apartments in Ontario would have the same chance of being represented as those who live in houses in Alberta. As a data analyst, you'll find that creating sample sizes usually takes place before you even get to the data. But it's still good for you to know that the data you're going to analyze is representative of the population and works with your objective. It's also good to know what's coming up in your data journey. In the next video, you'll have the option to become even more comfortable with sample sizes. See you there! Hey there! We've all probably dreamed of having a superpower at least once in our lives. I know I have. I'd love to be able to fly. But there's another superpower you might not have heard of: statistical power. Statistical power is the probability of getting meaningful results from a test. I'm guessing that's not a superpower any of you have dreamed about. Still, it's a pretty great data superpower. For data analysts, your projects might begin with a test or study. Hypothesis testing is a way to see if a survey or experiment has meaningful results. Here's an example. Let's say you work for a restaurant chain that's planning a marketing campaign for their new milkshakes. You need to test the ad on a group of customers before turning it into a nationwide ad campaign. In the test, you want to check whether customers like or dislike the campaign. You also want to rule out any factors outside of the ad that might lead them to say they don't like it. Using all your customers would be too time-consuming and expensive. So you'll need to figure out how many customers you'll need to show that the ad is effective. 50 probably wouldn't be enough. Even if you randomly chose 50 customers, you might end up with customers who don't like milkshakes at all. And if that happens, you won't be able to measure the effectiveness of your ad in getting more milkshake orders, since no one in the sample size would order them. That's why you need a larger sample size, so you can make sure you get a good number of all types of people for your test. Usually, the larger the sample size, the greater the chance you'll have statistically significant results with your test. And that's statistical power. In this case, using as many customers as possible will show the actual differences between the groups who like or dislike the ad versus people whose decision wasn't based on the ad at all. There are ways to accurately calculate statistical power, but we won't go into them here. You might need to calculate it on your own as a data analyst. For now, you should know that statistical power is usually shown as a value out of 1. So if your statistical power is 0.6, that's the same thing as saying 60%. In the milkshake ad test, if you found a statistical power of 60%, that means there's a 60% chance of you getting a statistically significant result on the ad's effectiveness. Statistically significant is a term that is used in statistics. If you want to learn more about the technical meaning, you can search online. But in basic terms, if a test is statistically significant, It means the results of the test are real and not an error caused by random chance. So there's a 60% chance that the results of the milkshake ad test are reliable and real, and a 40% chance that the result of the test is wrong. Usually, you need a statistical power of at least 0.8 or 80% to consider your results statistically significant. Let's check out one more scenario. We'll stick with milkshakes because I like milkshakes. Imagine you work for a restaurant chain that wants to launch a brand new birthday cake flavored milkshake. This milkshake will be more expensive to produce than your other milkshakes. Your company hopes that the buzz around the new flavor will bring in more customers and money to offset this cost. They want to test this out in a few restaurant locations first. So let's figure out how many locations you'd have to use to be confident in your results. First, you'd have to think about what might prevent you from getting statistically significant results. Are there restaurants running any other promotions that might bring in new customers? Do some restaurants have customers that always buy the newest item no matter what it is? Do some locations have construction that recently started that would prevent customers from even going to the restaurant? To get a higher statistical power, you'd have to consider all of these factors before you decide how many locations to include in your sample size for your study. You want to make sure any effect is most likely due to the new milkshake flavor, not another factor. The measurable effects would be an increase in sales or the number of customers at the locations in your sample size. That's it for now. Coming up, we'll explore sample sizes in more detail so you can get a better idea of how they impact your tests and studies. In the meantime, you've gotten to know a little bit more about milkshakes and superpowers, and, of course, statistical power. Sadly, only statistical power can truly be useful for data analysts. Though putting on my cape and flying to grab a milkshake right now does sound pretty good. Great to see you again. In this video, we'll go into more detail about sample sizes and data integrity. If you've ever been to a store that hands out samples, you know it's one of life's little pleasures. For me, anyway. Those small samples are also a very smart way for businesses to learn more about their products from customers without having to give everyone a free sample. A lot of organizations use sample size in a similar way. They take one part of something larger, in this case, a sample of a population. Sometimes they'll perform complex tests on their data to see if it meets their business objectives. We won't go into all the calculations needed to do this effectively. Instead, we'll focus on a big picture look at the process and what it involves. As a quick reminder, sample size is a part of a population that is representative of the population. For businesses, it's a very important tool. It can be both expensive and time-consuming to analyze an entire population of data. So using sample size usually makes the most sense and can still lead to valid and useful findings. There are handy calculators online that can help you find sample size. You need to input the confidence level, population size, and margin of error. We've talked about population size before. To build on that, we'll learn about confidence level and margin of error. Knowing about these concepts will help you understand why you need them to calculate sample size. The confidence level is the probability that your sample accurately reflects the greater population. You can think of it the same way as confidence in anything else. It's how strongly you feel that you can rely on something or someone. Having a 99% confidence level is ideal, but most industries hope for at least a 90 or 95% confidence level. Industries like pharmaceuticals usually want a confidence level that's as high as possible when they are using a sample size. This makes sense because they're testing medicines and need to be sure they work and are safe for everyone to use. For other studies, organizations might just need to know that the test or survey results have them heading in the right direction. For example, if a paint company is testing out new colors, a lower confidence level is okay. You also want to consider the margin of error for your study. You'll learn more about this soon, but it basically tells you how close your sample size results are to what your results would be if you use the entire population that your sample size represents. Think of it like this. Let's say that the principal of a middle school approaches you with a study about students' candy preferences. They need to know an appropriate sample size and they need it now. The school has a student population of 500, and they're asking for a confidence level of 95% and a margin of error of 5%. We've set up a calculator in a spreadsheet, but you can also easily find this type of calculator by searching sample size calculator on the internet. And just like those calculators, our spreadsheet calculator doesn't show any of the more complex calculations for figuring out sample size. So all we need to do is input the numbers for our population, confidence level, and margin of error. And when we type 500 for our population size and 95 for our confidence level percentage and 5 for our margin of error percentage, the result is about 218. That means for this study, an appropriate sample size would be 218. So if we surveyed 218 students and found that 55% of them preferred chocolate, then we could be pretty confident that would be true of all 500 students. 218 is the minimum number of people we need to survey based on our criteria of a 95% confidence level and a 5% margin of error. And in case you're wondering, the confidence level and margin of error don't have to add up to 100%. They're independent of each other. So let's say we change our margin of error from 5% to 3%. Then we find that our sample size would need to be larger, about 341 instead of 218, to make the results of the study more representative of the population. Feel free to practice with an online calculator. Knowing sample size and how to find it will help you when you work with data. And we've got more useful knowledge coming your way, including learning about margin of error. See you soon! Hey there! Earlier, we touched on margin of error without explaining it completely. Well, we're going to right that wrong in this video by explaining margin of error more. We'll even include an example of how to calculate it. As a data analyst, it's important for you to figure out sample size and variables like confidence level and margin of error before running any kind of test or survey. It's the best way to make sure your results are objective, and it gives you a better chance of getting statistically significant results. But if you already know the sample size, like when you're given survey results to analyze, you can calculate the margin of error yourself. Then you'll have a better idea of how much of a difference there is between your sample and your population. We'll start at the beginning with a more complete definition. Margin of error is the maximum amount that the sample results are expected to differ from those of the actual population. Let's think about an example of margin of error. It would be great to survey or test an entire population, but it's usually impossible or impractical to do this. So instead, we take a sample of the larger population. Based on the sample size, the resulting margin of error will tell us how different the results might be compared to the results if we had surveyed the entire population. Margin of error helps you understand how reliable the data from your hypothesis testing is. The closer to zero the margin of error, the closer your results from your sample would match results from the overall population. For example, let's say you completed a nationwide survey using a sample of the population. You asked people who work 5-day work weeks whether they like the idea of a 4-day work week. So your survey tells you that 60% prefer a 4-day work week. The margin of error was 10%, which tells us that between 50 and 70% like the idea. So if we were to survey all 5-day workers nationwide, between 50 and 70% would agree with our results. Keep in mind, our range is between 50 and 70%. That's because the margin of error is counted in both directions from the survey results of 60%. If you set up a 95% confidence level for your survey, there will be a 95% chance that the entire population's responses will fall between 50 and 70% saying, yes, they want a 4-day work week. Since your margin of error overlaps with that 50% mark, You can't say for sure that the public likes the idea of a 4-day workweek. In that case, you'd have to say your survey was inconclusive. Now, if you wanted a lower margin of error, say 5% with a range between 55 and 65%, you could increase the sample size. But if you've already been given the sample size, you can calculate the margin of error yourself. Then you can decide yourself how much of a chance your results have of being statistically significant based on your margin of error. In general, the more people you include in your survey, the more likely your sample is representative of the entire population. Decreasing the confidence level would also have the same effect, but that would also make it less likely that your survey is accurate. So to calculate margin of error, you need 3 things: population size, sample size, and confidence level. And just like with sample size, you can find lots of calculators online by searching margin of error calculator. But we'll show you in a spreadsheet, just like we did when we calculated sample size. Let's say you're running a study on the effectiveness of a new drug. You have a sample size of 500 participants, whose condition affects 1% of the world's population. That's about 80 million people, which is the population for your study. Since it's a drug study, you need to have a confidence level of 99%. You also need a low margin of error. Let's calculate it. We'll put the numbers for population and confidence level and sample size in the appropriate spreadsheet cells. And our result is a margin of error of close to 6%, plus or minus. When the drug study is complete, you'd apply the margin of error to your results to determine how reliable your results might be. Calculators like this one in the spreadsheet are just one of the many tools you can use to ensure data integrity. And it's also good to remember that checking for data integrity and aligning the data with your objectives will put you in good shape to complete your analysis. Knowing about sample size, statistical power, margin of error, and other topics we covered will help your analysis run smoothly. That's a lot of new concepts to take in. If you'd like to review them at any time, you can find them all in the glossary, or feel free to rewatch the video. Soon you'll explore the ins and outs of clean data. The data adventure keeps moving. I'm so glad you're moving along with it. You got this! Can you guess what inaccurate or bad data costs businesses every year? Thousands of dollars? Millions? Billions? Well, according to IBM, the yearly cost of poor quality data is $3.1 trillion in the US alone. That's a lot of zeros. Now, can you guess the #1 cause of poor quality data? It's not a new system implementation or a computer technical glitch. The most common factor is actually human error. Here's a spreadsheet from a law office. It shows customers, the legal services they bought, the service order number, how much they paid, and the payment method. Dirty data can be the result of someone typing in a piece of data incorrectly, inconsistent formatting, blank fields, or the same piece of data being entered more than once, which causes duplicates. Dirty data is data that's incomplete, incorrect, or irrelevant to the problem you're trying to solve. When you work with dirty data, you can't be sure that your results are correct. In fact, you can pretty much bet they won't be. Earlier, you learned that data integrity is critical to reliable data analytics results. And clean data helps you achieve data integrity. Clean data is data that's complete, correct, and relevant to the problem you're trying to solve. When you work with clean data, you'll find that your projects go much more smoothly. I remember the first time I witnessed firsthand how important clean data really is. I had just started using SQL and I thought it worked like magic. I could have the computer sum up millions of numbers, saving me tons of time and effort. But I quickly discovered that only works when the data is clean. If there was even one accidental letter in a column that should only have numbers, the computer wouldn't know what to do. So it would throw an error, and suddenly I was stuck. And there's no way I can add up millions of numbers by myself. So I had to clean up that data to make it work. The good news is that there's plenty of effective processes and tools to help you do that. Coming up, you'll gain the skills and knowledge you need to make sure the data you work with is always clean. Along the way, we'll dig deeper into the difference between clean and dirty data and why clean data is so important. We'll also talk about different ways to clean your data and common problems to look for during the process. Ready to start? Let's do it! Clean data is incredibly important for effective analysis. If a piece of data is entered into a spreadsheet or database incorrectly, or if it's repeated, or if a field is left blank, or if data formats are inconsistent, the result is dirty data. Small mistakes can lead to big consequences in the long run. Now, I'll be completely honest with you. Data cleaning is like brushing your teeth. It's something you should do and do properly because otherwise it can cause serious problems. For teeth, that might be cavities or gum disease. For data, that might be costing your company money or an angry boss. But here's the good news. If you keep brushing twice a day, every day, it becomes a habit. Soon, you don't even have to think about it. And it's the same with data. Trust me, it'll make you look great when you take the time to clean up that dirty data. As a quick refresher, dirty data is incomplete, incorrect, or irrelevant to the problem you're trying to solve. It can't be used in a meaningful way, which makes analysis very difficult, if not impossible. On the other hand, clean data is complete, correct, and relevant to the problem you're trying to solve. This allows you to understand and analyze the information and identify important patterns, connect related information, and draw useful conclusions. Then you can apply what you learn to make effective decisions. In some cases, you won't have to do a lot of work to clean data. For example, when you use internal data that's been verified and cared for by your company's data engineers and data warehouse team, it's more likely to be clean. Let's talk about some people you'll work with as a data analyst. Data engineers transform data into a useful format for analysis and give it a reliable infrastructure. This means they develop, maintain, and test databases, data processors, and related systems. Data warehousing specialists develop processes and procedures to effectively store and organize data. They make sure that data is available, secure, and backed up to prevent loss. When you become a data analyst, you can learn a lot by working with the person who maintains your databases to learn about their systems. If data passes through the hands of a data engineer or data warehousing specialist first, you know you're off to a good start on your project. There's a lot of great career opportunities as a data engineer or a data warehousing specialist. If this kind of work sounds interesting to you, maybe your career path will involve helping organizations save lots of time, effort, and money by making sure their data is sparkling clean. But even if you go in a different direction with your data analytics career and have the advantage of working with data engineers and warehousing specialists, you're still likely to have to clean your own data. And it's important to remember, no data set is perfect. It's always a good idea to examine and clean data before beginning analysis. Here's an example. Let's say you're working on a project where you need to figure out how many people use your company's software program. You have a spreadsheet that was created internally and verified by a data engineer and a data warehousing specialist. Check out the column labeled username. Now, it might seem logical that you can just scroll down and count the rows to figure out how many users you have. But that won't work because one person sometimes has more than one username. Maybe they registered from different email addresses, or maybe they have a work and personal account. In situations like this, you would need to clean the data by eliminating any rows that are duplicates. Once you've done that, there won't be any more duplicate entries. Then your spreadsheet's ready to be put to work. Okay, so far we've discussed working with internal data. But data cleaning becomes even more important when working with external data, especially if it comes from multiple sources. Let's say the software company from our example surveyed its customers to learn how satisfied they are with its software product. But when you review the survey data, you find that you have several nulls. A null is an indication that a value does not exist in a dataset. Note that it's not the same as a zero. In the case of our survey, a null would mean the customer skipped that question. A zero would mean they provided zero as their response. To do your analysis, you would first need to clean this data. Step 1 would be to decide what to do with those nulls. You could either filter them out and communicate that you now have a smaller sample size, or you can keep them in and learn from the fact that the customers did not provide responses. There's lots of reasons why this could have happened. Maybe your survey questions weren't written as well as they could be. Maybe they were confusing or biased, something we learned about earlier. Okay, we've touched on the basics of cleaning internal and external data, but there's lots more to come. Soon we'll learn about the common errors to be aware of to ensure your data is complete, correct, and relevant. See you soon!
I'm Angie. I'm a program manager of engineering at Google. I truly believe that cleaning data is the heart and soul of data. It's how you get to know your data, its quirks, its flaws, its mysteries. I love a good mystery. I remember one time I found somebody had purchased, I think it was $1 million worth of chicken sandwiches in one transaction. And this mystery drove me nuts. I had all these questions. Could this have really happened? Maybe it was a really big birthday party. How did they make $1 million worth of chicken sandwiches? And I, was cleaning my data and trying to figure out where did it go wrong. And we ended up finding out that we had been squaring and multiplying all of our transactions for a very specific case. It took us about 3 days to figure this out. I will never forget the moment when it was like, aha, we got to the bottom of it. The result is our data, was cleaned and we had this great data set that we could use for analysis. But what I loved was just the mystery of it, and getting to know all these weird intricacies about my data set. And it felt like a superpower almost. Like I was a detective and I'd gone in there and I'd really solved something. So I love cleaning data.
Hey there! In this video, we'll focus on common issues associated with dirty data. These include spelling and other text errors, inconsistent labels, formats, and field length, missing data, and duplicates. This will help you recognize problems quicker and give you the information you need to fix them when you encounter something similar during your own analysis. This is incredibly important in data analytics. Okay, let's go back to our law office spreadsheet. As a quick refresher, we'll start by checking out the different types of dirty data it shows. Sometimes, someone might key in a piece of data incorrectly. Other times, they might not keep data formats consistent. It's also common to leave a field blank. That's also called a null, which we learned about earlier. And if someone adds the same piece of data more than once, that creates a duplicate. So let's break that down. Then we'll learn about a few other types of dirty data and strategies for cleaning it. Misspellings, spelling variations, mixed up letters, inconsistent punctuation, and typos in general happen when someone types in a piece of data incorrectly. As a data analyst, you'll also deal with different currencies. For example, one dataset could be in US dollars and another in euros, and you don't want to get them mixed up. We want to find these types of errors and fix them like this. You'll learn more about this soon. Clean data depends largely on the data integrity rules that an organization follows, such as spelling and punctuation guidelines. For example, a beverage company might ask everyone working in its database to enter data about volume in fluid ounces instead of cups. It's great when an organization has rules like this in place. It really helps minimize the amount of data cleaning required. But it can't eliminate it completely. Like we discussed earlier, there's always the possibility of human error. The next type of dirty data our spreadsheet shows is inconsistent formatting. In this example, something that should be formatted as currency is shown as a percentage. Until this error is fixed, like this, the law office will have no idea how much money this customer paid for its services. We'll learn about different ways to solve this and many other problems soon. We discussed nulls previously, but as a reminder, nulls are empty fields. This kind of dirty data requires a little more work than just fixing a spelling error or changing a format. In this example, the data analysts would need to research which customer had a consultation on July 4th, 2020. Then, when they find the correct information, they'd have to add it to the spreadsheet. Another common type of dirty data is a duplicate. Maybe two different people added this appointment on August 13th, not realizing that someone else had already done it. Or maybe the person entering the data hit copy and paste by accident. Whatever the reason, it's the data analyst's job to identify this error and correct it by deleting one of the duplicates. Okay, now let's continue on to some other types of dirty data. The first has to do with labeling. To understand labeling, imagine trying to get a computer to correctly identify panda bears among images of all different kinds of animals. You need to show the computer thousands of images of panda bears. They're all labeled as panda bears. Any incorrectly labeled picture, like the one here that's just bear, will cause a problem. The next type of dirty data is having an inconsistent field length. You learned earlier that a field is a single piece of information from a row or a column of a spreadsheet. Field length is a tool for determining how many characters can be keyed into a field. Assigning a certain length to the fields in your spreadsheet is a great way to avoid errors. For instance, if you have a column for someone's birth year, you know the field length is 4 because all years are 4 digits long. Some spreadsheet applications have a simple way to specify field lengths and make sure users can only enter a certain number of characters into a field. This is part of data validation. Data validation is a tool for checking the accuracy and quality of data before adding or importing it. Data validation is a form of data cleansing, which you'll learn more about soon. But first, you'll get familiar with more techniques for cleaning data. This is a very important part of the data analyst's job, and I look forward to sharing these data cleaning strategies with you. Hi! Now that you're familiar with some of the most common types of dirty data, it's time to clean them up. As you've learned, clean data is essential to data integrity and reliable solutions and decisions. The good news is that spreadsheets have all kinds of tools you can use to get your data ready for analysis. The techniques for data cleaning will be different depending on the specific data set you're working with. So we won't cover everything you might run into. But this will give you a great starting point for fixing the types of dirty data analysts find most often. Think of everything that's coming up as a teaser trailer of data cleaning tools. I'm going to give you a basic overview of some common tools and techniques, and then we'll practice them again later on. Here, we'll discuss how to remove unwanted data, clean up text to remove extra spaces and blanks, fix typos, and make formatting consistent. However, before removing unwanted data, it's always a good practice to make a copy of the dataset. That way, if you remove something that you end up needing in the future, you can easily access it and put it back in the dataset. Once that's done, then you can move on to getting rid of the duplicates or data that isn't relevant to the problem you're trying to solve. Typically, duplicates appear when you're combining datasets from more than one source, or using data from multiple departments within the same business. You've already learned a bit about duplicates, but let's practice removing them once more now using this spreadsheet, which lists members of a professional logistics association. Duplicates can be a big problem for data analysts, so it's really important that you can find and remove them before any analysis starts. Here's an example of what I'm talking about. Let's say this association has duplicates of one person's $500 membership in its database. When the data is summarized, the analyst would think there was $1,000 being paid by this member and would make decisions based on that incorrect data. But in reality, this member only paid $500. These problems can be fixed manually, but most spreadsheet applications also offer lots of tools to help you find and remove duplicates. Now, irrelevant data, which is data that doesn't fit the specific problem that you're trying to solve, also needs to be removed. Going back to our association membership list example, let's say a data analyst was working on a project that focused only on current members. They wouldn't want to include information on people who are no longer members. Or who never joined in the first place. Removing irrelevant data takes a little more time and effort because you have to figure out the difference between the data you need and the data you don't. But believe me, making those decisions will save you a ton of effort down the road. The next step is removing extra spaces and blanks. Extra spaces can cause unexpected results when you sort, filter, or search through your data. And because these characters are easy to miss, they can lead to unexpected and confusing results. For example, if there's an extra space in a member ID number, when you sort the column from lowest to highest, this row will be out of place. To remove these unwanted spaces or blank cells, you can delete them yourself. Or, again, you can rely on your spreadsheets, which offer lots of great functions for removing spaces and blanks automatically. The next data cleaning step involves fixing misspellings, inconsistent capitalization, incorrect punctuation, and other typos. These types of errors can lead to some big problems. Let's say you have a database of emails that you use to keep in touch with your customers. If some emails have misspellings, a period in the wrong place, or any other kind of typo, not only do you run the risk of sending an email to the wrong people, you also run the risk of spamming random people. Think about our association membership example again. Misspelling might cause the data analyst to miscount the number of professional members if they sorted this membership type, and then counted the number of rows. Like the other problems we've come across, you can also fix these problems manually. Or you can use spreadsheet tools such as spell check, autocorrect, and conditional formatting to make your life easier. There's also easy ways to convert text to lowercase, uppercase, or proper case, which is one of the things we'll check out again later. All right, we're getting there. The next step is removing formatting. This is particularly important when you get data from lots of different sources. Every database has its own formatting, which can cause the data to seem inconsistent. Creating a clean and consistent visual appearance for your spreadsheets will help make it a valuable tool for you and your team when making key decisions. Most spreadsheet applications also have a clear formats tool, which is a great time saver. Cleaning data is an essential step in increasing the quality of your data. Now you know lots of different ways to do that. In the next video, you'll take that knowledge even further and learn how to clean up data that's come from more than one source. Welcome back. So far, you learned a lot about dirty data and how to clean up the most common errors in a dataset. Now we're going to take that a step further and talk about cleaning up multiple datasets. Cleaning data that comes from 2 or more sources is very common for data analysts, but it does come with some interesting challenges. A good example is a merger, which is an agreement that unites two organizations into a single new one. In the logistics field, there's been lots of big changes recently, mostly because of the e-commerce boom. With so many people shopping online, it makes sense that the companies responsible for delivering these products to their homes are in the middle of a big shakeup. When big things happen in an industry, it's common for two organizations to team up and become stronger through a merger. Let's talk about how that'll affect our logistics association. As a quick reminder, this spreadsheet lists association member ID numbers, first and last names, addresses, how much each member pays in dues, when the membership expires, and the membership types. Now, let's think about what would happen if the International Logistics Association decided to get together with the Global Logistics Association in order to help their members handle the incredible demands of e-commerce. First, all the data from each organization would need to be combined using data merging. Data merging is the process of combining two or more datasets into a single dataset. This presents a unique challenge because when two totally different datasets are combined, the information is almost guaranteed to be inconsistent and misaligned. For example, the Global Logistics Association spreadsheet has a separate column for a person's suite, apartment, or unit number. But the International Logistics Association combines that information with their street address. This needs to be corrected to make the number of address columns consistent. Next, check out how the Global Logistics Association uses people's email addresses as their member ID, while the International Logistics Association uses numbers. This is a big problem because people in a certain industry, such as logistics, typically join multiple professional associations. So there's a very good chance that these datasets include membership information on the exact same person, just in different ways. It's super important to remove those duplicates. Also, the Global Logistics Association has many more member types than the other organization. On top of that, it uses the term young professional instead of student associate. But both describe members who are still in school or just starting their careers. If you were merging these two datasets, you need to work with your team to fix the fact that the two associations describe memberships very differently. Okay, now you understand why the merging of organizations also requires the merging of data. And that can be tricky. But there's lots of other reasons why data analysts merge datasets. For example, in one of my past jobs, I merged a lot of data from multiple sources to get insights about our customers' purchases. The kinds of insights I gained helped me identify customer buying patterns. When merging datasets, I always begin by asking myself some key questions to help me avoid redundancy and to confirm that the datasets are compatible. In data analytics, compatibility describes how well two or more datasets are able to work together. So the first question I would ask is, do I have all the data I need? To gather customer purchase insights, I wanted to make sure I had data on customers, their purchases, and where they shopped. Next, I would ask, does the data I need exist within these datasets? As you learned earlier in this program, this involves considering the entire dataset analytically. Looking through the data before I start using it lets me get a feel for what it's all about, what the schema looks like, if it's relevant to my customer purchase insights, and if it's clean data. That brings me to the next question. Do the datasets need to be cleaned, or are they ready for me to use? And because I'm working with more than one source, I'll also ask myself, are the datasets cleaned to the same standard? For example, what fields are regularly repeated? How are missing values handled? How recently was the data updated? Finding the answers to these questions and understanding if I need to fix any problems at the start of a project is a very important step in data merging. In both the examples we explored here, a data analyst could use either the spreadsheet tools or SQL queries to clean up, merge, and prepare the datasets for analysis. Depending on the tool you decide to use, the cleanup process can be simple or very complex. Soon you'll learn how to make the best choice for your situation. And as a final note, programming languages like R are also very useful for cleaning data. You'll learn more about how to use R and the other concepts we covered soon. Hi again. As you learned earlier, there's a lot of different ways to clean up data. I've shown you some examples of how you can clean data manually, such as searching for and fixing misspellings, or removing empty spaces and duplicates. We also learned that lots of spreadsheet applications have tools that help simplify and speed up the data cleaning process. There's a lot of great efficiency tools that data analysts use all the time, such as conditional formatting, removing duplicates, formatting dates, fixing text strings and substrings, and splitting text to columns. We'll explore those in more detail now. The first is something called conditional formatting. Conditional formatting is a spreadsheet tool that changes how cells appear when values meet specific conditions. Likewise, it can let you know when a cell does not meet the conditions you've set. Visual cues like this are very useful for data analysts, especially when we're working in a large spreadsheet with lots of data. Making certain data points stand out makes the information easier to understand and analyze. And for cleaning data, knowing when the data doesn't follow the condition is very helpful. Let's return to the Logistics Association spreadsheet to check out conditional formatting in action. We'll use conditional formatting to highlight blank cells. That way, we know where there's missing information, so we can add it to the spreadsheet. To do this, we'll start by selecting the range we want to search. For this example, we're not focused on address 3 and address 5. So the fields will include all the columns in our spreadsheets except for F and H. Next, we'll go to Format and choose Conditional Formatting. Great. Our range is automatically indicated in the field. The format rule will be to format cells if the cell is empty. Finally, we'll choose the formatting style. I'm going to pick a shade of bright pink so my blanks really stand out. Then click Done, and the blank cells are instantly highlighted. Okay, the next spreadsheet tool removes duplicates. As you've learned before, it's always smart to make a copy of the dataset before removing anything. So let's do that now. Great, now we can continue. You might remember that our example spreadsheet has one association member listed twice. To fix that, go to Data and select Remove Duplicates. Remove Duplicates is a tool that automatically searches for and eliminates duplicate entries from a spreadsheet. Choose Data has Header Row, because our spreadsheet has a row at the very top that describes the contents of each column. Next, select All, because we want to inspect our entire spreadsheet. Finally, remove duplicates. You'll notice the duplicate row was found and immediately removed. Another useful spreadsheet tool enables you to make formats consistent. For example, some of the dates in this spreadsheet aren't in a standard date format. This could be confusing if you wanted to analyze when association members joined, how often they renewed their memberships, or how long they've been with the association. To make all of our dates consistent, first select column J. Then go to Format, select Number, then Date. Now all of our dates have a consistent format. Before we go over the next tool, I want to explain what a text string is. In data analytics, a text string is a group of characters within a cell, most often composed of letters. An important characteristic of a text string is its length, which is the number of characters in it. You'll learn more about that soon. For now, it's also useful to know that a substring is a smaller subset of a text string. Okay, now let's talk about split. Split is a tool that divides a text string around a specified character and puts each fragment into a new and separate cell. Split is helpful when you have more than one piece of data in a cell, and you want to separate them out. This might be a person's first and last name listed together, or it could be a cell that contains someone's city, state, country, and zip code, but you actually want each of those in its own column. So, let's say this association wanted to analyze all of the different professional certifications its members have earned. To do this, you want each certification separated out into its own column. Right now, the certifications are separated by a comma. That's the specified text separating each item, also called the delimiter. Let's get them separated. Highlight the column, then select Data, and split text to columns. This spreadsheet application automatically knew that the comma was the delimiter and separated each certification. But sometimes you might need to specify what the delimiter should be. You can do that here. Split text to columns is also helpful for fixing instances of numbers stored as text. Sometimes values in your spreadsheet will seem like numbers, but they're formatted as text. This can happen when copying and pasting from one place to another, or if the formatting's wrong. For this example, let's check out a new spreadsheet from a cosmetics maker. If a data analyst wanted to determine total profits, they could add up everything in column F. But there's a problem. One of the cells has an error. If you check into it, you learn that the 707 in this cell is text and can't be changed into a number. So when the spreadsheet tries to multiply the cost of the product by the number of units sold, it's unable to make the calculation. But if we select the orders column and choose split text to columns, the error is resolved because now it can be treated as a number. Coming up, you'll learn about a tool that does just the opposite. Concatenate is a function that joins multiple text strings into a single string. Spreadsheets are a very important part of data analytics. They save data analysts time and effort and help us eliminate errors each and every day. Here, you learn about some of the most common tools that we use, but there's a lot more to come. Next, we'll learn even more about data cleaning with spreadsheet tools. Bye for now. Welcome back. You've learned about some very useful data cleaning tools that are built right into spreadsheet applications. Now we'll explore how functions can optimize your efforts to ensure data integrity. As a reminder, a function is a set of instructions that performs a specific calculation using the data in a spreadsheet. The first function we'll discuss is called countif. Countif is a function that returns the number of cells that match a specified value. Basically, it counts the number of times a value appears in a range of cells. Let's go back to our professional association spreadsheet. In this example, we want to make sure the association membership prices are listed accurately. We'll use countif to check for some common problems, like negative numbers or a value that's much less or much greater than expected. To start, let's find the least expensive membership, $100 for student associates. So that'll be the lowest number that exists in this column. If any cell has a value that's less than 100, countif will alert us. We'll add a few more rows at the bottom of our spreadsheet. Then beneath column H, type member dues less than $100. Next, type the function in the cell next to it. Every function has a certain syntax that needs to be followed for it to work. Syntax is a predetermined structure that includes all required information and its proper placement. The syntax of a COUNTIF function should be like this: equals COUNTIF, open parentheses, range, comma, the specified value in quotation marks, and a closed parentheses. So it will show up like this. Where I2 through I72 is the range, and the value is less than 100. This tells the function to go through column I and return a count of all cells that contain a number less than 100. Turns out there is one. Scrolling through our data, we find that one piece of data was mistakenly keyed in as a negative number. Let's fix that now. Now, we'll use COUNTIF to search for any values that are more than we would expect. The most expensive membership type is $500 for corporate members. Type the function in the cell. This time it'll appear like this. I2 through I72 is still the range, but the value is greater than 500. There's one here too. Check it out. This entry has an extra 0. It should be $100. Okay. The next function we'll discuss is called len. Len is a function that tells you the length of a text string by counting the number of characters it contains. This is useful when cleaning data if you have a certain piece of information in your spreadsheet that you know must contain a certain length. For example, this association uses 6-digit member identification codes. So if we just import this data and wanted to be sure our codes are all the correct number of digits, we'd use len. The syntax of len is equals len, open parentheses, the range, and the close parentheses. So we'll insert a new column after member ID, then type an equal sign and len. Add an open parentheses. The range is the first member ID number in A2. Finish the function by closing the parentheses. It tells us that there are 6 characters in cell A2. Let's continue the function through the entire column and find out if any results are not 6. But instead of manually going through our spreadsheet to search for these instances, we'll use conditional formatting. We talked about conditional formatting earlier. It's a spreadsheet tool that changes how cells appear when values meet specific conditions. Let's practice that now. Select all of column B except for the header, then go to Format and choose Conditional Formatting. The format rule is to format cells if not equal to 6. Click Done. And the cell with the 7 inside is highlighted. All right, now we're going to talk about left and right. Left is a function that gives you a set number of characters from the left side of a text string. Right is a function that gives you a set number of characters from the right side of a text string. As a quick reminder, a text string is a group of characters within a cell, commonly composed of letters, numbers, or both. To see these functions in action, let's go back to the spreadsheet from the cosmetics maker from earlier. This spreadsheet contains product codes. Each has a 5-digit numeric code and then a 4-character text identifier. But let's say we only want to work with one side or the other. You can use left or right to give you the specific set of characters or numbers you need. We'll practice cleaning up our data using the left function first. The syntax of left is equals left, open parentheses, the range, a comma, and the number of characters from the left side of the text string we want. Then we finish it with the close parentheses. Here, our project requires just the 5-digit numeric codes. So in a separate column, type equals left, open parentheses, then add the range. Our range is A2. Then add a comma, and the number 5 for our 5-digit product code. Finally, finish the function with the close parentheses. Our function should show up like this. Press enter, and now we have a substring, which is the number part of the product code only. Click and drag this function through the entire column to separate out the rest of the product codes by number only. Okay, now let's say our project only needs the 4-character text identifier. For that, we'll use the right function. In the next column, we'll begin the function. The syntax is equals right, open parentheses, the range, a comma, and the number of characters we want. Then we finish with the close parentheses. Let's key that in now. Equals right, open parentheses, and the range is still A2. Add a comma, and this time we'll tell it that we want the first 4 characters from the right. Close up the parentheses, and press enter. Then drag the function throughout the entire column. Now we can analyze the products in our spreadsheet based on either substring, the 5-digit numeric code, or the 4-character text identifier. So hopefully that makes it clear how you can use left and right to extract substrings from the left and right sides of a string. Now let's learn how you can extract something in between. Here's where we'll use something called mid. Mid is a function that gives you a segment from the middle of a text string. This cosmetics company lists all of its clients using a client code. It's composed of the first 3 letters of the city where the client's located, its state abbreviation, and then a 3-digit identifier. But let's say a data analyst needs to work with just the states in the middle. The syntax for mid is equals mid, open parentheses, the range, then a comma. When using mid, you always need to supply a reference point. In other words, you need to set where the function should start. After that, place another comma and how many middle characters you want. In this case, our range is D2. Let's start the function in a new column. Type equals mid, open parentheses, D2. Then the first 3 characters represent a city name. So that means the starting point is the 4th. Add a comma and 4. We also need to tell the function how many middle characters we want. Add 1 more comma and 2, because the state abbreviations are 2 characters long. Press enter, and bam! We just get the state abbreviation. Continue the mid function through the rest of the column. So we've learned about a few functions that help separate out specific text strings. But what if we want to combine them instead? For that, we'll use concatenate, which is a function that joins together 2 or more text strings. The syntax is equals concatenate, then an open parentheses. Inside, indicate each text string you want to join, separated by commas. Then finish the function with the closed parentheses. So just for practice, Let's say we needed to rejoin the left and right text strings back into complete product codes. In a new column, let's begin our function. Type equals concatenate, then an open parentheses. The first text string we want to join is in H2. Then add a comma. The second part is in I2. Add a closed parentheses and press enter. Drag it down through the entire column. And just like that, all of our product codes are back together. Okay, the last function we'll learn about here is trim. Trim is a function that removes leading, trailing, and repeated spaces in data. Sometimes, when you import data, your cells have extra spaces which can get in the way of your analysis. For example, if this cosmetics maker wanted to look up a specific client name, it won't show up in the search if it has extra spaces. You can use trim to fix that problem. The syntax for trim is equals trim, open parentheses, your range, and close parentheses. So in a separate column, type equals trim and an open parentheses. The range is C2, as you want to check out the client names. Close the parentheses and press enter. Finally, continue the function down the column. Trim fixed the extra spaces. So now we know some very useful functions that can make your data cleaning even more successful. This was a lot of information. So as always, feel free to go back and review the video and then practice on your own. We'll continue building on these tools soon, and you'll also have a chance to practice. Pretty soon, these data cleaning steps will become second nature, like brushing your teeth. Hi, let's get into it. Motivational speaker Wayne Dyer once said, "If you change the way you look at things, the things you look at change." This is so true in data analytics. No two analytics projects are ever exactly the same. So it only makes sense that different projects require us to focus on different information differently. In this video, we'll explore different methods that data analysts use to look at data differently, and how that leads to more efficient and effective data cleaning. Some of these methods include sorting and filtering, pivot tables, a function called VLOOKUP, and plotting to find outliers. Let's start with sorting and filtering. As you learned earlier, sorting and filtering data helps data analysts customize and organize the information the way they need for a particular project. But these tools are also very useful for data cleaning. You might remember that sorting involves arranging data into a meaningful order to make it easier to understand, analyze, and visualize. For data cleaning, you can use sorting to put things in alphabetical or numerical order so you can easily find a piece of data. Sorting can also bring duplicate entries closer together for faster identification. Filters, on the other hand, are very useful in data cleaning when you want to find a particular piece of information. You learned earlier that filtering means showing only the data that meets a specific criteria while hiding the rest. This lets you view only the information you need. When cleaning data, you might use a filter to only find values above a certain number, or just even or odd values. Again, this helps you find what you need quickly and separates out the information you want from the rest. That way, you can be more efficient when cleaning your data. Another way to change the way you view data is by using pivot tables. You've learned that a pivot table is a data summarization tool that is used in data processing. Pivot tables sort, reorganize, group, count, total, or average data stored in a database. In data cleaning, pivot tables are used to give you a quick, clutter-free view of your data. You can choose to look at the specific parts of a data set you need and get a visual in the form of a pivot table. Let's create one now, using our cosmetic maker's spreadsheet again. To start, select the data we want to use. Here, we'll choose the entire spreadsheet. Select Data, then Pivot Table. Choose New Sheet and Create. Let's say we're working on a project that requires us to look at only the most profitable products, items that earn the cosmetics maker at least $10,000 in orders. So the row we'll include is total, for total profits. We'll sort in descending order to put the most profitable items at the top, and we'll show totals. Next, we'll add another row for products, so that we know what those numbers are about. We can clearly determine that the most profitable products have the product codes 15143EXFO and 32729MASC. We can ignore the rest for this particular project because they fall below 10,000 in orders. Now, we might be able to use context clues that assume we're talking about exfoliants and mascaras. But we don't know which ones or if that assumption is even correct. So we need to confirm what the product codes correspond to. And this brings us to the next tool. It's called VLOOKUP. VLOOKUP stands for vertical lookup. It's a function that searches for a certain value in a column to return a corresponding piece of information. When data analysts look up information for a project, it's rare for all of the data they need to be in the same place. Usually, you'll have to search across multiple sheets or even different databases. The syntax of VLOOKUP is equals VLOOKUP, open parentheses, then the data you want to look up. Next is a comma, and where you want to look for that data. In our example, this will be the name of a spreadsheet, followed by exclamation point. The exclamation point indicates that we're referencing a cell in a different sheet from the one we're currently working in. Again, that's very common in data analytics. Okay, next is the range in the place where you're looking for data, indicated using the first and last cell separated by a colon. After one more comma is the column in the range containing the value to return. Next, another comma and the word false, which means that an exact match is what we're looking for. Finally, complete your function by closing the parentheses. To put it simply, VLOOKUP searches for the value in the first argument in the leftmost column of the specified location. Then, the value of the third argument tells VLOOKUP to return the value in the same row from the specified column. The false tells VLOOKUP that we want an exact match. Soon, you'll learn the difference between exact and approximate matches, but for now, just know that VLOOKUP takes the value in one cell and searches for a match in another place. Let's begin. We'll type equals VLOOKUP, then add the data we want to look for, which is the product code. The dollar signs make sure that the corresponding part of the reference remains unchanged or locked. You can lock just the column, just the row, or both at the same time. Next, we'll tell it to look at sheet 2 in both columns. we add a 2 to represent the second column. The last term, false, says we want an exact match. With this information, we can now analyze the data for only the most profitable products. Going back to the 2 most profitable products, we can search for 15143EXFO and 32729MASC. Go to Edit, and then Find. Type in the product codes, and search for them. Now we can learn which products we'll be using for this particular project. The final tool we'll talk about is something called plotting. When you plot data, you put it in a graph, chart, table, or other visual to help you quickly find what it looks like. Plotting is very useful when trying to identify any skewed data or outliers. For example, if we wanted to make sure the price of each product is correct, we could create a chart. This would give us a visual aid that helps us quickly figure out if anything looks like an error. So let's select the column with our prices. Then we'll go to Insert and choose Chart. Pick a column chart as the type. One of these prices looks extremely low. If we look into it, we discover that this item has a decimal point in the wrong place. It should be $7.30, not 73 cents. That would have a big impact on our total profits, so it's a good thing we caught that during data cleaning. Looking at data in new and creative ways helps data analysts identify all kinds of dirty data. Coming up, you'll continue practicing these new concepts so you can get more comfortable with them. You'll also learn additional strategies for ensuring your data is clean, and we'll provide you with effective insights. Great work so far! Hello! So far, you learned about a lot of different tools and functions that analysts use to clean up data for analysis. Now, we'll take a step back and talk about some of the really big picture aspects of clean data. Knowing how to fix specific problems, either manually with spreadsheet tools or with functions, is extremely valuable. But it's also important to think about how your data has moved between systems and how it's evolved along its journey to your data analysis project. To do this, data analysts use something called data mapping. Data mapping is the process of matching fields from one database to another. This is very important to the success of data migration, data integration, and lots of other data management activities. As you learned earlier, different systems store data in different ways. For example, the state field in one spreadsheet might show Maryland spelled out, but another spreadsheet might store it as MD. Data mapping helps us note these kinds of differences, so we know when data is moved and combined, it will be compatible. As a quick reminder, compatibility describes how well 2 or more datasets are able to work together. So the first step to data mapping is identifying what data needs to be moved. This includes the tables and the fields within them. We also need to define the desired format for the data once it reaches its destination. To figure out how this works, let's go back to the merger between our 2 logistics associations. Starting with the first data field, we'll identify that we need to move both sets of member IDs. And to define the desired format, we'll choose whether to use numbers, like this spreadsheet, or email addresses, like the other spreadsheet. Next comes mapping the data. Depending on the schema and number of primary and foreign keys in a data source, data mapping can be simple or very complex. As a reminder, a schema is a way of describing how something is organized. A primary key references a column in which each value is unique. And a foreign key is a field within a table that is a primary key in another table. For more challenging projects, there's all kinds of data mapping software programs you can use. These data mapping tools will analyze field by field how to move data from one place to another. Then they automatically clean, match, inspect, and validate the data. They also create consistent naming conventions, ensuring compatibility when the data is transferred from one source to another. When selecting a software program to map your data, you want to be sure that it supports the file types you're working with, such as Excel, SQL, Tableau, and others. Later on, you'll learn more about selecting the right tool for a particular task. For now, let's practice mapping data manually. First, we need to determine the content of each section to make sure the data ends up in the right place. For example, the data on when memberships expire would be consolidated into a single column. This step makes sure that each piece of information ends up in the most appropriate place in the merged data source. Now, you might remember that some of the data was inconsistent between the two organizations, like the fact that one uses a separate column for suite, apartment, or unit number, but the other doesn't. This brings us to the next step, transforming the data into a consistent format. This is a great time to use concatenate. As you learned before, concatenate is a function that joins together two or more text strings, which is what we did earlier with our cosmetics company example. So we'll insert a new column and then type equals concatenate. Then the two text strings we want to make one. Drag that through the entire column. And now we have the consistency in the new merged association lists of member addresses. Okay, now that everything's compatible, it's time to transfer the data to its destination. There's a lot of different ways to move data from one place to another, including querying, import wizards, and even simple drag and drop. All right, here's our merged spreadsheet. It looks good, but we still want to make sure everything was transferred properly. So we'll go into the testing phase of data mapping. For this, you inspect a sample piece of data to confirm that it's clean and properly formatted. It's also a smart practice to do spot checks on things such as the number of nulls. For the test, you can use a lot of the data cleaning tools we discussed previously, such as data validation, conditional formatting, count if, sorting, and filtering. Finally, once you've determined that the data is clean and compatible, you can start using it for analysis. Data mapping is so important because even one mistake when merging data can ripple throughout an organization, causing the same error to appear again and again. This leads to poor results. On the other hand, data mapping can save the day by giving you a clear roadmap you can follow to make sure your data arrives safely at its destination. And that's why you learn how to do it. Welcome back, and great job on that last weekly challenge. Now that we know the difference between clean and dirty data and some general data cleaning techniques, let's focus on data cleaning using SQL. Coming up, we'll learn about the different data cleaning functions in Spreadsheets and SQL. and how SQL can be used to clean large datasets. I'll also show you how to develop some basic search queries for databases, and how to apply basic SQL functions for transforming data and cleaning strings. Cleaning your data is the last step in the data analysis process before you can move on to the actual analysis. And SQL has a lot of great tools that can help you do that. But before we start cleaning databases, we'll take a closer look at SQL and when to use it. I'll see you there. Advertising agencies get money from their clients to advertise their brand, right? And so these agencies use our products, use certain Google platforms, advertising platforms, and I help them with how to best use those platforms, different strategies they can use to be best in class. A lot of the folks at the advertising agencies have reports that they have to send out to their clients. And so these reports take a lot of time to create and visualize. And so what I do is I help the practitioners and the analytics teams use a particular product that enables them to create those reports much faster and much easier. If you're going to start off as a data analyst, it opens tons of doors because everybody is tracking data, is using data, needs to use data, regardless of industry. So anywhere from healthcare to advertising to e-commerce to entertainment, anything and everything, everybody uses data. So everybody needs you as a data analyst. SQL makes our lives easier when we're analyzing lots of different data. It's only somewhat recently that the SQL programs that we use now can give us instant results for analyzing millions or billions of data. Years ago, maybe about like 5 years ago or so, even though we could still analyze those millions of rows, we would end up having to wait 15 minutes, 30 minutes for the queries to run, but now it's instantaneous. And so that's really exciting, and we can do so much more with that power. So SQL has helped a lot in my career because it's one of those fundamental things you have to know as a data analyst. Back in the day, not everyone used SQL, so knowing SQL was definitely a competitive advantage. Nowadays, I would say more and more people, maybe most people know it. It's a core skill and highly sought after by everybody. So knowing SQL, becoming a data analyst makes you popular, quite popular from recruiters. So I think that's really fun. I taught myself SQL. So my knowledge about SQL is something I hold near and dear, close to my heart, since it's something that almost I've made for myself. And I feel so much satisfaction from it. So that's why I really like SQL. One of the fun things about SQL, and another reason why I really enjoy using it, is because when you type something in, that query, and you just hit Control-Enter, or once you run the query, you get the results almost instantly, depending on the platform you use. But it's fascinating to see, if you think conceptually, how much analysis the computer is doing for you based on that little bit of command code or the little bit of code you wrote. And it's just so powerful if you think about what's happening behind the scenes. So I think that's kind of fun to look at. We live in a world of big data, and it keeps getting bigger. The computing power is also increasing exponentially. So with all the data that we can track, the more and more we can track that data, the more and more we need data analysts. And so our career prospects are basically skyrocketing. I'm Sally. I'm a measurement and analytical lead at Google. Hello again. So before we go over all the ways data analysts use SQL to clean data, I want to formally introduce you to SQL. We've talked about SQL a lot already. You've seen some databases and some basic functions in SQL. And you've even seen how SQL can be used to process data. But now let's actually define SQL. SQL is structured query language that analysts use to work with databases. Data analysts usually use SQL to deal with large data sets because it can handle huge amounts of data, and I mean trillions of rows. That's a lot of rows to wrap your head around. So let me give you an idea about how much data that really is. Imagine a data set that contains the name of all 8 billion people in the world. It would take the average person 101 years to read all 8 billion names. SQL can process this in seconds. Personally, I think that's pretty cool. Other tools like spreadsheets might take a really long time to process that much data, which is one of the main reasons data analysts choose to use SQL when dealing with big data sets. Let me give you a short history on SQL. Development on SQL actually began in the early 70s. In 1970, Edgar F. Codd developed a theory about relational databases. You might remember learning about relational databases a while back. This is a database that contains a series of tables that can be connected to form relationships. At the time, IBM was using a relational database management system called System R. Well, IBM computer scientists were trying to figure out a way to manipulate and retrieve data from IBM's System R. Their first query language was hard to use, so they quickly moved on to the next version, SQL. In 1979, after extensive testing, SQL, now just spelled SQL, was released publicly. By 1986, SQL had become the standard language for relational database communication, and it still is. This is another reason why data analysts choose SQL. It's a well-known standard within the community. The first time I used SQL to pull data from a real database was for my first job as a data analyst. I didn't have any background knowledge about SQL before that. I only found out about it because it was a requirement for that job. The recruiter for that position gave me a week to learn it. So I went online and researched it and ended up teaching myself SQL. They actually gave me a written test as part of the job application process. I had to write SQL queries and functions on a whiteboard. But I've been using SQL ever since, and I really like it. And just like I learned SQL on my own, I wanted to remind you that you can figure things out yourself too. There's tons of great online resources for learning, so don't let one job requirement stand in your way without doing some research first. Now that we know a little more about why analysts choose to work with SQL when they're handling a lot of data, and a little bit about the history of SQL, we'll move on and learn some practical applications for it. Coming up next, we'll check out some of the tools we learned in Spreadsheets and figure out if any of those apply to working in SQL. Spoiler alert, they do. See you soon. Hey there! So far, we've learned about both Spreadsheets and SQL. While there's lots of differences between Spreadsheets and SQL, you'll find some similarities too. So let's check out what Spreadsheets and SQL have in common and how they're different. Spreadsheets and SQL actually have a lot in common. Specifically, there's tools you can use in both Spreadsheets and SQL to achieve similar results. We've already learned about some tools for cleaning data in Spreadsheets, which means you already know some tools that you can use in SQL. For example, you can still perform arithmetic, use formulas, and join data when you're using SQL. So we'll build on the skills we've learned in Spreadsheets and use them to do even more complex work in SQL. Here's an example of what I mean by more complex work. If we were working with health data for a hospital, we need to be able to access and process a lot of data. We might need demographic data like patients' names, birthdays, and addresses, information about their insurance or past visits, public health data, or even user-generated data to add to their patient records. All of this data is being stored in different places, maybe even in different formats. And each location might have millions of rows and hundreds of related tables. This is way too much data to input manually, even for just one hospital. That's where SQL comes in handy. Instead of having to look at each individual data source and record it in our spreadsheet, we can use SQL to pull all this information from different locations in our database. Now, let's say we want to find something specific in all this data, like how many patients with a certain diagnosis came in today. In a spreadsheet, we can use the COUNTIF function to find that out. Or we can combine the count and where queries in SQL to find out how many rows match our search criteria. This will give us similar results, but works with a much larger and more complex set of data. Next, let's talk about how spreadsheets and SQL are different. First, it's important to understand that spreadsheets and SQL are different things. Spreadsheets are generated with a program like Excel or Google Sheets. These programs are designed to execute certain built-in functions. SQL, on the other hand, is a language that can be used to interact with database programs like Oracle MySQL or Microsoft SQL Server. The differences between the two are mostly in how they're used. If a data analyst was given data in the form of a spreadsheet, they'll probably do their data cleaning and analysis within that spreadsheet. But if they're working with a large data set with more than 1 million rows or multiple files within a database, It's easier, faster, and more repeatable to use SQL. SQL can access and use a lot more data because it can pull information from different sources in the database automatically, unlike spreadsheets, which only have access to the data you input. This also means the data is stored in multiple places. A data analyst might use spreadsheets stored locally on their hard drive or their personal cloud when they're working alone. But if they're on a larger team with multiple analysts who need to access and use data stored across a database, SQL might be a more useful tool. Because of these differences, spreadsheets and SQL are used for different things. As you already know, spreadsheets are good for smaller data sets and when you're working independently. Plus, spreadsheets have built-in functionalities like spell check that can be really handy. SQL is great for working with larger data sets, even trillions of rows of data. And because SQL has been the standard language for communicating with databases for so long, it can be adapted and used for multiple database programs. SQL also records changes in queries, which makes it easy to track changes across your team if you're working collaboratively. Next, we'll learn more queries and functions in SQL that will give you some new tools to work with. You might even learn how to use spreadsheet tools in brand new ways. See you next time. Hey, welcome back. So far, we've learned that SQL has some of the same tools as spreadsheets, but on a much larger scale. In this video, we'll learn some of the most widely used SQL queries that you can start using for your own data cleaning and eventual analysis. Let's get started. We've talked about queries as requests you put into the database to ask it to do things for you. Queries are a big part of using SQL. It's structured query language after all. Queries can help you do a lot of things, but there's some common ones that data analysts use all the time. So let's start there. First, I'll show you how to use the select query. I've called this one out before, but now I'll add some new things for us to try out. Right now, the table viewer is blank because we haven't pulled anything from the database yet. For this example, the store we're working with is hosting a giveaway for customers in certain cities. We have a database containing customer information that we can use to narrow down which customers are eligible for the giveaway. So let's do that now. We can use select to specify exactly what data we want to interact with in a table. And if we combine select with from, we can pull data from any table in this database, as long as we know what the columns and rows are named. We might want to pull the data about customer names and cities from one of the tables. To do that, we can input select name, city from customer underscore data dot customer underscore address. To get this information from the customer underscore address table, which lives in the customer underscore data dataset. So select and from help specify what data we want to extract from the database and use. We can also insert new data into a database or update existing data. For example, maybe we have a new customer that we want to insert into this table. We can use the insert into query to put that information in. So let's start with where we're trying to insert this data, the customer underscore address table. We also want to specify which columns we're adding this data to by typing their names in the parentheses. That way, SQL can tell the database exactly where we're inputting new information. Then, we'll tell it what values we're putting in. Run the query, and just like that, it added it to our table for us. Now, let's say we just need to change the address of a customer. Well, we can tell the database to update it for us. To do that, we need to tell it we're trying to update the customer underscore address table. Then, we need to let it know what value we're trying to change. But we also need to tell it where we're making that change specifically, so that it doesn't change every address in the table. There. Now, this one customer's address has been updated. If we want to create a new table for this database, we can use the create table if not exists statement. Keep in mind, just running a SQL query doesn't actually create a table for the data we extract. It just stores it in our local memory. To save it, we'll need to download it as a spreadsheet or save the results into a new table. As a data analyst, there's a few situations where you might need to do just that. It really depends on what kind of data you're pulling and how often. If you're only using a total number of customers, you probably don't need a CSV file or new table in your database. If you're using the total number of customers per day to do something like track a weekend promotion in a store, you might download that data as a CSV file so you can visualize it in a spreadsheet. But if you're being asked to pull this trend on a regular basis, you can create a table that will automatically refresh with the query you've written. That way, you can directly download the results whenever you need them for a report. Another good thing to keep in mind, if you're creating lots of tables within a database, you'll want to use the drop table if exists statement to clean up after yourself. It's good housekeeping. You probably won't be deleting existing tables very often. After all, that's the company's data, and you don't want to delete important data from their database. But you can make sure you're cleaning up the tables you've personally made so that there aren't old or unused tables with redundant information cluttering the database. There. Now you've seen some of the most widely used SQL queries in action. There's definitely more query keywords for you to learn, and unique combinations that'll help you work within databases. But this is a great place to start. Coming up, we'll learn even more about queries in SQL and how to use them to clean our data. See you next time.
Hi, I'm Evan, and I'm a learning portfolio manager here at Google. I don't think I'm a computer science or a super engineering type, but I really like working with numbers. So naturally, I went into accounting. And about after 2 years of accounting, I said, wow, I really don't want to do all of this by hand. So I took my first information systems class where they taught me the language SQL or SQL. And it completely opened up my mind. Between a working knowledge of spreadsheets where you change one cell and the whole spreadsheet changes because of those amazing calculated fields, and SQL where I can query billions of rows of data in a matter of seconds, I was completely sold on my love for data. And I've dedicated my life and my career to just communicating that passion and getting folks excited about the things that they can do with their data. Why is SQL such an amazing first language to pick up? Well, there's so many things that you can do with it. I will first caveat and say, I am not a computer science major. I don't know deep down Java and Python. And I was a little bit apprehensive of learning a computer language. It's kind of like a pseudo programming language, but in reality, you can write your first SQL statement, as you're going to find out here, in just 5 minutes or less. SQL, honestly, it's one of those languages that's easy to learn and even more fun to master. I've been learning SQL for 15 years. I've been teaching it for 10. As you're going to see in some of these hands-on labs you'll be working through, it's very easy to return data from within a database or a data set. Just select whatever columns from whichever database that you're pulling from, and immediately you get the data back. Now, the really fun part is actually teasing apart and saying, I wonder if I change my query, add these more columns, filter this data set a different way, share it with my colleagues. It's meant to be an interactive querying language. And query means asking a question. So if I could challenge you one thing, it's that the syntax for picking up SQL, much like the rules of a chess game, are very easy to pick up. But the hard part is actually not the syntax writing, much like with any programming language, but the actual what question do you want to ask of your data? So what I would encourage you to do is be super curious about whatever data set that you're given. Spend a lot of time even before you touch your keyboard in thinking about what data set or what insights you can get from your data, and then start having fun. There's many different ways to write the same correct SQL statement. So try one out, share it with your friends, and then start returning that data back for insights. Good luck.
It's so great to have you back. Now that we know some basic SQL queries and spent some time working in a database, let's apply that knowledge to something else we've been talking about: preparing and cleaning data. You already know that cleaning and completing your data before you analyze it is an important step. So in this video, I'll show you some ways SQL can help you do just that, including how to remove duplicates as well as 4 functions to help you clean string variables. Earlier, we covered how to remove duplicates in spreadsheets using the Remove Duplicates tool. In SQL, we can do the same thing by including distinct in our select statement. For example, let's say the company we work for has a special promotion for customers in Ohio. We want to get the customer IDs of customers who live in Ohio, but some customer information has been entered multiple times. We can get these customer IDs by writing select customer underscore ID from customer underscore data dot customer underscore address. This query will give us duplicates if they exist in the table. If customer ID 9080 shows up 3 times in our table, our results will have 3 of that customer ID. But we don't want that. We want a list of all unique customer IDs. To do that, we add distinct to our select statement by writing select distinct customer underscore ID from customer underscore data dot customer underscore address. Now, the customer ID 9080 will show up only once in our results. You might remember we talked before about text strings as a group of characters within a cell, commonly composed of letters, numbers, or both. These text strings need to be cleaned sometimes. Maybe they've been entered differently in different places across your database, and now they don't match. In those cases, you'll need to clean them before you can analyze them. So here are some functions you can use in SQL to handle string variables. You might recognize some of these functions from when we talked about spreadsheets. Now it's time to see them work in a new way. Pull up the dataset we shared right before this video, and you can follow along step by step with me during the rest of this video. The first function I want to show you is length, which we've encountered before. If we already know the length our string variables are supposed to be, we can use length to double check that our string variables are consistent. For some databases, this query is written as len, but it does the same thing. Let's say we're working with the customer underscore address table from our earlier example. We can make sure that all country codes have the same length by using length on each of these strings. So to write our SQL query, let's first start with select and from. We know our data comes from the customer underscore address table within the customer underscore data dataset. So we add customer underscore data dot customer underscore address after the from clause. Then under select, we'll write length and then the column we want to check, country. To remind ourselves what this is, we can label this column in our results as letters underscore in underscore country. So we add as letters underscore in underscore country after length parentheses country. The result we get is a list of the number of letters in each country listed for each of our customers. It seems that almost all of them are 2s, which means the country field contains only 2 letters. But we notice one that has 3. That's not good. We want our data to be consistent. So let's check out which countries were incorrectly listed in our table. We can do that by putting the length parentheses country parentheses function that we created into the where clause, because we're telling SQL to filter the data to show only customers whose country contains more than 2 letters. So now we'll write select country from customer underscore data dot customer underscore address, where length parentheses country parentheses greater than 2. When we run this query, we now get the 2 countries where the number of letters is greater than the 2 we expect to find. The incorrectly listed countries show up as USA instead of US. If we created this table, then we could update our table so that this entry shows up as US instead of USA. But in this case, we didn't create this table, so we shouldn't update it. We still need to fix this problem so we can pull a list of all the customers in the US, including the 2 that have USA instead of US. The good news is that we can account for this error in our results by using the substring function in our SQL query. To write our SQL query, let's start by writing the basic structure. Select from where. We know our data is coming from the customer underscore address table from the customer underscore data dataset. So we type in customer underscore data dot customer underscore address after from. Next, we tell SQL what data we want it to give us. We want all the customers in the US by their IDs, so we type in customer underscore ID after select. Finally, we want SQL to filter out only American customers. So we use the substring function after the where clause. We're going to use the substring function to pull the first 2 letters of each country so that all of them are consistent and only contain 2 letters. To use the substring function, we first need to tell SQL the column where we found this error, country. Then we specify which letter to start with. We want SQL to pull the first 2 letters, so we're starting with the first letter. So we type in 1. Then we need to tell SQL how many letters including this first letter to pull. Since we want the first 2 letters, we need SQL to pull 2 total letters. So we type in 2. This will give us the first 2 letters of each country. We want US only, so we'll set this function to equals US. When we run this query, we get a list of all customer IDs of customers whose country is the US, including the customers that had USA instead of US. Going through our results, it seems like we have a couple duplicates where the customer ID is shown multiple times. Remember how we get rid of duplicates? We add distinct before customer underscore ID. So now when we run this query, we have our final list of customer IDs of the customers who live in the US. Finally, let's check out the trim function, which you've come across before. This is really useful if you find entries with extra spaces and need to eliminate those extra spaces for consistency. For example, let's check out the state column in our customer underscore address table. Just like we did for the country column, we want to make sure the state column has the consistent number of letters. So let's use the length function again to learn if we have any state that has more than 2 letters, which is what we would expect to find in our data table. We start writing our SQL query by typing the basic SQL structure of select from where. We're working with the customer underscore address table in the customer underscore data dataset, so we type in customer underscore data dot customer underscore address after from. Next, we tell SQL what we want it to pull. We want it to give us any state that has more than 2 letters. So we type in state after select. Finally, we want SQL to filter for states that have more than 2 letters. This condition is written in the where clause. So we type in length, parentheses, state, parentheses, and that it must be greater than 2, because we want the states that have more than 2 letters. We want to figure out what the incorrectly listed states look like, if we have any. When we run this query, we get 1 result. we have one state that has more than 2 letters. But hold on. How can this state that seems like it has 2 letters, O and H for Ohio, have more than 2 letters? We know that there are more than 2 characters because we use the length parentheses state parentheses greater than 2 statement in the where clause when filtering our results. So that means the extra characters that SQL is counting must then be a space. There must be a space after the H. This is where we would use the trim function. The trim function removes any spaces. So let's write a SQL query that accounts for this error. Let's say we want a list of all customer IDs of the customers who live in OH for Ohio. We start with the basic SQL structure. Select, from, where. We know the data comes from the customer underscore address table and the customer underscore data dataset. So we type in customer underscore data dot customer underscore address after from. Next, we tell SQL what data we want. We want SQL to give us the customer IDs of customers who live in Ohio. So we type in customer underscore ID after select. Since we know we have some duplicate customer entries, we'll go ahead and type in distinct before customer ID to remove any duplicate customer IDs from appearing in our results. Finally, we want SQL to give us the customer IDs of the customers who live in Ohio. We're asking SQL to filter the data, so this belongs in the where clause. Here's where we'll use the trim function. To use the trim function, we tell SQL the column we want to remove spaces from, which is state in our case. And we want only Ohio customers, so we type in equals OH. That's it. We have all customer IDs of the customers who live in Ohio, including that customer with the extra space after the H. Making sure that your string variables are complete and consistent will save you a lot of time later by avoiding errors or miscalculations. That's why we clean data in the first place. Hopefully, functions like length, substring, and trim will give you the tools you need to start working with string variables in your own datasets. Next up, we'll check out some other ways you can work with strings and more advanced cleaning functions. Then you'll be ready to start working in SQL on your own. See you soon. Hi there, and welcome back. So far, we've gone over some basic SQL queries and functions that can help you clean your data. We've also checked out some ways you can deal with string variables in SQL to make your job easier. Get ready to learn more functions for dealing with strings in SQL. Trust me, these functions will be really helpful in your work as a data analyst. In this video, we'll check out strings again and learn how to use the cast function to correctly format data. When you import data that doesn't already exist in your SQL tables, the data types from the new dataset might not have been imported correctly. This is where the cast function comes in handy. Basically, cast can be used to convert anything from one data type to another. Let's check out an example. Imagine we're working with Lauren's Furniture Store. The owner has been collecting transaction data for the past year, but she just discovered that they can't actually organize their data because it hadn't been formatted correctly. So we'll help her by converting her data to make it useful again. For example, let's say we want to sort all purchases by purchase underscore price in descending order. That means we want the most expensive purchase to show up first in our results. To write the SQL query, we start with the basic SQL structure. Select, from, where. We know the data is stored in the customer underscore purchase table in the customer underscore data dataset. So we write customer underscore data dot customer underscore purchase after from. Next, we tell SQL what data to give us in the select clause. We want to see the purchase underscore price data, so we type purchase underscore price after select. Next is the where clause. We are not filtering out any data since we want all purchase prices shown, so we can take out the where clause. Finally, to sort the purchase underscore price in descending order, we type order by purchase underscore price DESC at the end of our query. Let's run this query. We see that 89.85 shows up at the top with 799.99 below it. But we know that 799.99 is a bigger number than 89.85. The database doesn't recognize that these are numbers, so it didn't sort them that way. If we go back to the customer underscore purchase table and take a look at its schema, we can see what data type the database thinks purchase underscore price is. It says here, the database thinks purchase underscore price is a string, when in fact it is a float, which is a number that contains a decimal. That is why 89.85 shows up before 799.99. When we sort letters, we start from the first letter before moving on to the second letter. So if we want to sort the words apple and orange in descending order, we start with the first letters, A and O. Since O comes after A, orange will show up first, then apple. The database did the same with 89.85 and 799.99. It started with the first letter, which in this case was a 8 and 7, respectively. Since 8 is bigger than 7, the database sorted 89.85 first and then 799.99 because the database treated these as text strings. The database doesn't recognize these strings as floats because they haven't been typecast to match that data type yet. Typecasting means converting data from one type to another, which is what we'll do with the cast function. We use the cast function to replace purchase underscore price with a new purchase underscore price that the database recognizes as float instead of string. We start by replacing purchase underscore price with cast. Then we tell SQL the field we want to change, which is the purchase underscore price field. Next is the data type we want to change purchase underscore price to, which is the float data type. We also need to sort by this new field, so we change purchase underscore price after order by to cast parentheses purchase underscore price as float 64. This is how we use the cast function to allow SQL to recognize the purchase underscore price column as floats instead of text strings. Now we can sort our purchases by purchase underscore price. And just like that, Lauren's Furniture Store has data that can actually be used for analysis. As a data analyst, you'll be asked to locate and organize data a lot, which is why you want to make sure you convert between data types early on. Businesses like our furniture store are interested in timely sales data, and you need to be able to account for that in your analysis. The cast function can be used to change strings into other data types too, like date and time. As a data analyst, you may find yourself using data from various sources. Part of your job is to make sure the data from those sources is recognizable and usable in your database, so that you won't run into any issues with your analysis. And now you know how to do that. The cast function is one great tool you can use when you're cleaning data. And coming up, we'll cover some other advanced functions that you can add to your toolbox. See you soon! Hey there! Great to see you again! So far, we've seen some SQL functions in action. In this video, we'll go over more uses for cast and then learn about concat and coalesce. Let's get started. So earlier, we talked about the cast function, which lets us typecast text strings into floats. I called out that the cast function can be used to change into other data types too. So let's check out another example of how you can use cast in your own data work. We've got the transaction data we were working with from our Lauren's Furniture Store example. But now we'll check out the purchase date field. The furniture store owner has asked us to look at purchases that occurred during their sales promotion period in December. Let's write a SQL query that will pull date and purchase underscore price for all purchases that occurred between December 1st, 2020 and December 31st, 2020. We start by writing the basic SQL structure. Select from where. We know the data comes from the customer underscore purchase table in the customer underscore data dataset. So we write customer underscore data dot customer underscore purchase after from. Next, we tell SQL what data to pull. Since we want date and purchase underscore price, we add them into the select statement. Finally, we want SQL to filter for purchases that occurred in December only. So we type date between 2020-12-01 and 2020-12-31 in the where clause. Let's run the query. 4 purchases occurred in December, but the date field looks odd. That's because the database recognizes the date field as date time, which consists of the date and time. Our SQL query still works correctly even if the date field is date time instead of date. But we can tell SQL to convert the date field into the date data type, so we see just the date and not the time. To do that, we use the cast function again. So we'll use the cast function to replace the date field in our select statement with the new date field that will show the date and not the time. We can do that by typing cast and adding the date as the field we want to change. Then we tell SQL the data type we want instead, which is the date data type. There. Now we can have cleaner results for purchases that occurred during the December sales period. Cast is a super useful function for cleaning and sorting data, which is why I wanted you to see it in action one more time. Next up, let's check out the concat function. Concat lets you add strings together to create new text strings that can be used as unique keys. Going back to our customer underscore purchase table, we see that the furniture store sells different colors of the same product. The owner wants to know if customers prefer certain colors, so the owner can manage store inventory accordingly. The problem is, the product underscore code is the same regardless of the product color. We need to find another way to separate products by color, so we can tell if customers prefer one color over the others. So we'll use concat to produce a unique key that'll help us tell the products apart by color and count them more easily. Let's write our SQL query by starting with the basic structure. Select from where. We know our data comes from the customer underscore purchase table in the customer underscore data dataset. So we type customer underscore data dot customer underscore purchase after from. Next, we tell SQL what data to pull. We use the concat function here to get that unique key of product and color. So we type concat. The first column we want, product underscore code, and the other column we want, product underscore color. Finally, let's say we want to look at couches. So we filter for couches by typing product equals couch in the where clause. Now we can count how many times each couch was purchased and figure out if customers preferred one color over the others. With concat, the furniture store can find out which color couches are the most popular and order more. I've got one last advanced function to show you, coalesce. Coalesce can be used to return non-null values in a list. Null values are missing values. If you have a field that's optional in your table, it'll have null in that field for rows that don't have appropriate values to put there. Let's open the customer underscore purchase table so I can show you what I mean. In the customer underscore purchase table, we can see a couple rows where product information is missing. That is why we see nulls there. But for the rows where product name is null, we see that there is product underscore code data that we can use instead. We'd prefer SQL to show us the product name, like bed or couch, because it's easier for us to read. But if the product name doesn't exist, we can tell SQL to give us the product underscore code instead. That is where the coalesce function comes into play. Let's say we wanted a list of all products that were sold. We want to use the product name column to understand what kind of product was sold. So we write our SQL query with the basic SQL structure, select from where. We know our data comes from customer underscore purchase table in the customer underscore data dataset. So we type customer underscore data dot customer underscore purchase after from. Next, we tell SQL the data we want. We want a list of product names, but if names aren't available, then give us the product code. Here is where we type coalesce. Then we tell SQL which column to check first, product, and which column to check second if the first column is null, product underscore code. We'll name this new field as product underscore info. Finally, we are not filtering out any data, so we can take out the where clause. This gives us product information for each purchase. Now we have a list of all products that were sold for the owner to review. Coalesce can save you time when you're making calculations too, by skipping any null values and keeping your math correct. Those were just some of the advanced functions you can use to clean your data and get it ready for the next step in the analysis process. You'll discover more as you continue working in SQL. But that's the end of this video and this module. Great work! We've covered a lot of ground. You learned the different data cleaning functions in spreadsheets and SQL, and the benefits of using SQL to deal with large data sets. We also added some SQL formulas and functions to your toolkit. And most importantly, we got to experience some of the ways that SQL can help you get data ready for your analysis. After this, you'll get to spend some time learning how to verify and report your cleaning results so that your data is squeaky clean and your stakeholders know it. But before that, you've got another weekly challenge to tackle. You've got this. Some of these concepts might seem challenging at first, but they'll become second nature to you as you progress in your career. It just takes time and practice. Speaking of practice, feel free to go back to any of these videos and rewatch or even try some of these commands on your own. Good luck, and I'll see you again when you're ready. Hi there, great to have you back. You've been learning a lot about the importance of clean data and explored some tools and strategies to help you throughout the cleaning process. In these videos, we'll be covering the next step in the process, verifying and reporting on the integrity of your clean data. Verification is a process to confirm that a data cleaning effort was well executed and the resulting data is accurate and reliable. It involves rechecking your clean dataset, doing some manual cleanups if needed, and taking a moment to sit back and really think about the original purpose of the project. That way, you can be confident that the data you collected is credible and appropriate for your purposes. Making sure your data is properly verified is so important because it allows you to double-check that the work you did to clean up your data was thorough and accurate. For example, you might have referenced an incorrect cell phone number or accidentally keyed in a typo. Verification lets you catch mistakes before you begin analysis. Without it, any insights you gain from analysis can't be trusted for decision-making. You might even risk misrepresenting populations or damaging the outcome of a product that you're actually trying to improve. I remember working on a project where I thought the data I had was sparkling clean because I'd used all the right tools and processes. But when I went through the steps to verify the data's integrity, I discovered a semicolon that I had forgotten to remove. Sounds like a really tiny error, I know, but if I hadn't caught the semicolon during verification and removed it, it would have led to some big changes in my results. And that, of course, could have led to different business decisions. So there's an example of why verification is so crucial. But that's not all. The other big part of the verification process is reporting on your efforts. Open communication is a lifeline for any data analytics project. And reports are a super effective way to show your team that you're being 100% transparent about your data cleaning. Reporting is also a great opportunity to show stakeholders that you're accountable, build trust with your team, and make sure you're all on the same page about important project details. Coming up, you'll learn different strategies for reporting, like creating data cleaning reports, documenting your cleaning process, and using something called the changelog. A changelog is a file containing a chronologically ordered list of modifications made to a project. It's usually organized by version and includes the date, followed by a list of added, improved, and removed features. Changelogs are very useful for keeping track of how a dataset evolved over the course of a project. They're also another great way to communicate and report on data to others. Along the way, you'll also see some examples of how verification and reporting can help you avoid repeating mistakes and save you and your team time. Ready to get started? Let's go! In this video, we'll discuss how to begin the process of verifying your data cleaning efforts. Verification is a critical part of any analysis project. Without it, you have no way of knowing that your insights can be relied on for data-driven decision-making. Think of verification as a stamp of approval. To refresh your memory, verification is a process to confirm that a data cleaning effort was well executed and the resulting data is accurate and reliable. It also involves manually cleaning data to compare your expectations with what's actually present. The first step in the verification process is going back to your original unclean dataset and comparing it to what you have now. Review the dirty data and try to identify any common problems. For example, maybe you had a lot of nulls. In that case, you check your clean data to ensure no nulls are present. To do that, you could search through the data manually or use tools like conditional formatting or filters. Or maybe there was a common misspelling, like someone keying in the name of a product incorrectly over and over again. In that case, you'd run a find in your clean data to make sure no instances of the misspelled word occur. Another key part of verification involves taking a big picture view of your project. This is an opportunity to confirm you're actually focusing on the business problem that you need to solve and the overall project goals, and to make sure that your data is actually capable of solving that problem and achieving those goals. It's important to take the time to reset and focus on the big picture, because projects can sometimes evolve or transform over time without us even realizing it. Maybe an e-commerce company decides to survey 1,000 customers to get information that would be used to improve a product. But as responses begin coming in, the analysts notice a lot of comments about how unhappy customers are with the e-commerce website platform altogether. So the analysts start to focus on that. While the customer buying experience is of course important for any e-commerce business, it wasn't the original objective of the project. The analysts, in this case, need to take a moment to pause, refocus, and get back to solving the original problem. Taking a big picture view of your project involves doing 3 things. First, consider the business problem you're trying to solve with the data. If you've lost sight of the problem, you have no way of knowing what data belongs in your analysis. Taking a problem-first approach to analytics is essential at all stages of any project. You need to be certain that your data will actually make it possible to solve your business problem. Second, you need to consider the goal of the project. It's not enough just to know that your company wants to analyze customer feedback about a product. What you really need to know is that the goal of getting this feedback is to make improvements to that product. On top of that, you also need to know whether the data you've collected and cleaned will actually help your company achieve that goal. And third, you need to consider whether your data is capable of solving the problem and meeting the project objectives. That means thinking about where the data came from and testing your data collection and cleaning processes. Sometimes data analysts can be too familiar with their own data, which makes it easier to miss something or make assumptions. Asking a teammate to review your data from a fresh perspective and getting feedback from others is very valuable in this stage. This is also the time to notice if anything sticks out to you as suspicious or potentially problematic in your data. Again, step back, take a big picture view, and ask yourself, do the numbers make sense? Let's go back to our e-commerce company example. Imagine an analyst is reviewing the cleaned up data from the customer satisfaction survey. The survey was originally sent to 1,000 customers. But what if the analyst discovers there's more than 1,000 responses in the data? This could mean that the customer figured out a way to take the survey more than once. Or it could also mean that something went wrong in the data cleaning process and the field was duplicated. Either way, this is a signal that it's time to go back to the data cleaning process and correct the problem. Verifying your data ensures that the insights you gain from analysis can be trusted. It's an essential part of data cleaning that helps companies avoid big mistakes. This is another place where data analysts can save the day. Coming up, we'll go through the next steps in the data cleaning process. See you there. Hey there! In this video, we'll continue building on the verification process. As a quick reminder, the goal is to ensure that our data cleaning work was done properly and the results can be counted on. You want your data to be verified so you know it's 100% ready to go. It's sort of like car companies running tons of tests to make sure a car is safe before it hits the road. You learn that the first step in verification is returning to your original, uncleaned dataset and comparing it to what you have now. This is an opportunity to search for common problems. After that, you clean up the problems manually, for example, by eliminating extra spaces or removing an unwanted quotation mark. But there's also some great tools for fixing common errors automatically, such as trim and remove duplicates. Earlier, you learned that trim is a function that removes leading, trailing, and repeated spaces in data. And remove duplicates is a tool that automatically searches for and eliminates duplicate entries from a spreadsheet. Now, sometimes you have an error that shows up repeatedly, and it can't be resolved with a quick manual edit or a tool that fixes the problem automatically. In these cases, it's helpful to create a pivot table. A pivot table is a data summarization tool that is used in data processing. Pivot tables sort, reorganize, group, count, total, or average data stored in a database. We'll practice that now using the spreadsheet from a party supply store. Let's say this company was interested in learning which of its 4 suppliers is most cost-effective. So an analyst pulled this data on the products the business sells, how many were purchased, which supplier provides them, the cost of the products, and the ultimate revenue. The data's been cleaned, but during verification, we noticed that one of the suppliers' names was keyed in incorrectly. We could just correct the word as plus, but this might not solve the problem, because we don't know if this was a one-time occurrence or if the problem's repeated throughout the spreadsheet. There are 2 ways to answer that question. The first is using find and replace. Find and replace is a tool that looks for a specified search term in a spreadsheet and allows you to replace it with something else. So we'll choose Edit, then Find and Replace. We're trying to find PLOS, the misspelling of plus in the supplier's name. In some cases, you might not want to replace the data. You just want to find something. No problem. Just type the search term, leave the rest of the options as default, and click Done. But right now, we do want to replace it with PLUS. So we'll type that in here. Then click Replace All, and Done. There we go. Our misspelling has been corrected. That was, of course, the goal. But for now, let's undo our find and replace so we can practice another way to determine if errors are repeated throughout a dataset, like with the pivot table. We'll begin by selecting the data we want to use. Choose column C, select Data, then Pivot Table. Choose New Sheet and Create. We know this company has 4 suppliers. So if we count the suppliers and the number doesn't equal 4, we know there's a problem. So first, add a row for suppliers. Next, we'll add a value for our suppliers. And summarize by count A. Count A counts the total number of values within a specified range. Here, we're counting the number of times a supplier's name appears in column C. Note that there's also a function called count, which only counts the numerical values within a specified range. If we used it here, the result would be 0, not what we have in mind. But in other spreadsheet applications, count would give us information we want for our current example. As you continue learning more about formulas and functions, you'll discover more interesting options. If you want to keep learning, search online for spreadsheet formulas and functions. There's a lot of great information out there. Okay, so our pivot table has counted the number of misspellings, and it clearly shows that the error occurs just once. Otherwise, our 4 suppliers are accurately accounted for in our data. Now, we can correct the spelling, and we've verified that the rest of the supplier data is clean. This is also useful practice when querying a database. If you're working in SQL, you can address misspellings using a case statement. The case statement goes through 1 or more conditions and returns a value as soon as a condition is met. Let's discuss how this works in real life using our customer_name table. Check out how our customer Tony Magnolia shows up as Tony and Tinoi. Tony's name was misspelled. Let's say we want a list of our customer IDs and the customer's first names, so we can write personalized notes thanking each customer for their purchase. We don't want Tony's note to be addressed incorrectly to Tinoi. So here's where we can use the case statement. We'll start our query with the basic SQL structure. Select from where. We know the data comes from the customer_name table in the customer_data dataset, so we can add customer_data.customer_name after from. Next, we tell SQL what data to pull in the select clause. We want customer_ID and first_name. We can go ahead and add customer_ID after select. But for our customers' first names, we know that Tony was misspelled. So we'll correct that using case. We'll add case, and then when, and type first_name equal Tinoi. Next, we'll use the then command and type Tony, followed by the else command. Here we'll type first_name, followed by and as, and then we'll type cleaned_name. Finally, we are not filtering our data, so we can eliminate the where clause. As I mentioned, a case statement can cover multiple cases. If we wanted to search for a few more misspelled names, our statement would look similar to the original, with some additional names like this. And there you go. Now that you've learned how you can use spreadsheets and SQL to fix errors automatically, we'll explore how to keep track of our changes next. Hi again. Now that you've learned how to make your data squeaky clean, it's time to address all the dirt you've left behind. When you clean your data, all the incorrect or outdated information is gone, leaving you with the highest quality content. But all those changes you made to the data are valuable too. In this video, we'll discuss why keeping track of changes is important to every data project, and how to document all your cleaning changes to make sure everyone stays informed. This involves documentation, which is the process of tracking changes, additions, deletions, and errors involved in your data cleaning effort. You can think of it like a crime TV show. Crime evidence is found at the scene and passed on to the forensics team. They analyze every inch of the scene and document every step, so they can tell a story with the evidence. A lot of times, the forensic scientist is called to court to testify about that evidence, and they have a detailed report to refer to. The same thing applies to data cleaning. Data errors are the crime, data cleaning is gathering evidence, and documentation is detailing exactly what happened for peer review or court. Having a record of how a dataset evolved does three very important things. First, it lets us recover data cleaning errors. Instead of scratching our heads, trying to remember what we might have done 3 months ago, we have a cheat sheet to rely on if we come across the same errors again later. It's also a good idea to create a clean table rather than overwriting your existing table. This way, you still have the original data in case you need to redo the cleaning. Second, documentation gives you a way to inform other users of changes you've made. And if you ever go on vacation or get promoted, the analyst who takes over for you will have a reference sheet to check in with. Third, documentation helps you determine the quality of the data to be used in analysis. The first two benefits assume the errors aren't fixable. But if they are, a record gives the data engineer more information to refer to. It's also a great warning for ourselves that the dataset is full of errors and should be avoided in the future. If the errors were time-consuming to fix, it might be better to check out alternative datasets that we can use instead. Data analysts usually use a changelog to access this information. As a reminder, a changelog is a file containing a chronologically ordered list of modifications made to a project. You can use and view a changelog in Spreadsheets and SQL to achieve similar results. Let's start with the spreadsheet. We can use Sheets version history, which provides a real-time tracker of all the changes and who made them, from individual cells to the entire worksheet. To find this feature, click the File tab and then select Version History. In the right panel, choose an earlier version. We can find who edited the file and the changes they made in the color next to their name. To return to the current version, go to the top left and click Back. If you want to check out changes in a specific cell, we can right-click and select Show Edit History. That's it. Also, if you want others to be able to browse the sheet's version history, you'll need to assign permission. Okay, now let's switch gears and talk about SQL. The way you create and view a changelog with SQL depends on the software program you're using. Some companies even have their own separate software that keeps track of changelogs and important SQL queries. This gets pretty advanced. But essentially, all you have to do is specify exactly what you did and why when you commit a query to the repository as a new and improved query. This lets the company revert back to a previous version if something you've done crashes the system, which has happened to me before. Another option is to just add comments as you go while you're cleaning data in SQL. This will help you construct your changelog after the fact. For now, we'll check out BigQuery's query history, which tracks all the queries you've run. You can click on any of them to revert back to a previous version of your query, or to bring up an older version to find what you've changed. Here's what we've got. I'm in the Query History tab. Listed on the bottom right are all the queries I've run by date and time. You can click on this icon to the right of each individual query to bring it up to the query editor. Changelogs like these are a great way to keep yourself on track. It also lets your team get real-time updates when they want them. But there's another way to keep the communication flowing, and that's reporting. Stick around and you'll learn some easy ways to share your documentation, and maybe impress your stakeholders in the process. See you in the next video. Great, you're back. Let's set the stage. The crime is dirty data. We've gathered the evidence. It's been cleaned, verified, and cleaned again. Now it's time to present our evidence. We'll retrace the steps and present our case to our peers. As we discussed earlier, data cleaning, verifying, and reporting is a lot like a crime drama. Now it's our day in court. Just like a forensic scientist testifies on the stand about the evidence, data analysts are counted on to present their findings after a data cleaning effort. Earlier, we learned how to document and track every step of the data cleaning process, which means we have solid information to pull from. As a quick refresher, documentation is the process of tracking changes, additions, deletions, and errors involved in a data cleaning effort. Changelogs are a good example of this. Since it's saved chronologically, it provides a real-time account of every modification. Documenting will be a huge time saver for you as a future data analyst. It's basically a cheat sheet you can refer to if you're working with a similar dataset or need to address similar errors. While your team can view changelogs directly, stakeholders can't and have to rely on your report to know what you did. Let's check out how we might document our data cleaning process using an example we worked with earlier. In that example, we found that this association had 2 instances of the same membership for $500 in its database. We decided to fix this manually by deleting the duplicate info. There are plenty of ways we could go about documenting what we did. One common way is to just create a doc listing out the steps we took and the impact they had. For example, first on your list would be that you removed the duplicate instance. Which decreased the number of rows from 33 to 32. And lowered the membership total by $500. If we were working with SQL, we could include a comment in the statement describing the reason for a change, without affecting the execution of the statement. That's something a bit more advanced, which we'll talk about later. Regardless of how we capture and share our changelogs, we're setting ourselves up for success by being 100% transparent about our data cleaning. This keeps everyone on the same page and shows project stakeholders that we're accountable for effective processes. In other words, this helps build our credibility as witnesses who can be trusted to present all the evidence accurately during testimony. For dirty data, it's an open and shut case. Welcome back. By now, it's safe to say that verifying, documenting, and reporting are valuable steps in the data cleaning process. You have proof to give stakeholders that your data is accurate and reliable, and the effort to attain it was well executed and documented. The next step is getting feedback about the evidence and using it for good, which we'll cover in this video. Clean data is important to the task at hand, but the data cleaning process itself can reveal insights that are helpful to a business. The feedback we get when we report on our cleaning can transform data collection processes and ultimately business development. For example, one of the biggest challenges of working with data is dealing with errors. Some of the most common errors involve human mistakes, like mistyping or misspelling, flawed processes, like poor design of a survey form, and system issues, where older systems integrate data incorrectly. Whatever the reason, data cleaning can shine a light on the nature and severity of error-generating processes. With consistent documentation and reporting, we can uncover error patterns in data collection and entry procedures, and use the feedback we get to make sure common errors aren't repeated. Maybe we need to reprogram the way the data is collected, or change specific questions on a survey form. In more extreme cases, the feedback we get can even send us back to the drawing board to rethink expectations and possibly update quality control procedures. For example, sometimes it's useful to schedule a meeting with the data engineer or data owner to make sure the data is brought in properly and doesn't require constant cleaning. Once errors have been identified and addressed, stakeholders have data they can trust for decision-making. And by reducing errors and inefficiencies in data collection, the company just might discover big increases to its bottom line. Congratulations! You now have the foundation you need to successfully verify and report on your cleaning results. Stay tuned to keep building on your new skills. Hey there! Thanks for stopping by once again. So earlier we checked out some potential career paths that might open up for you once you complete the program. You might also have explored the advantages of networking and building an online presence. And I want to tell you, just by being here now, you've shown you're committed. You're taking a big step in your future career. Coming up, we'll spend some time building your resume. You might already have a resume that you've used or been saving, and that's great. There's a good chance you'll still be able to use it, even if you're planning to switch careers. Together, we'll find out what kinds of changes to your resume you might want to make. But before that, we'll figure out what the whole application process is like. Then we'll explore the best way to write or adjust your resume to make it as professional looking as possible and ready for your role as a data analyst. We'll also take a peek at some examples of other resumes. After that, we'll have you do a little self-analysis as we review the different types of data analyst jobs out there, so you can think about which ones might be best for you. While I'm definitely not a career counselor, we can still think of this as a kind of career counseling session. You'll get a better idea of how to build your resume while thinking about your bigger career picture at the same time. So let's get started. Hi again. Right now seems like the perfect time to take a step back from learning about data analytics, so you can get excited about what comes after you're done here. The road to finding a job can be challenging, but you're building up your skill set and learning what it takes to be a data analyst. In this video, we'll cover what you can expect from your job search, plus some tips to using your newfound skills and knowledge to make your search easier. I remember when I first started out, I reached out to as many people as I could to learn about their career paths, their companies, and their roles. I wanted to get a good idea of what to expect. And that's what we're doing now, giving you an idea of what to expect during your own job search. It's important to remember that everyone's search will be different. It might depend on where you live, what your interests are within the field, and personal preferences, like the type of work environment you feel comfortable in. This is all part of making this journey your own, as you hunt for a job that's perfect for you. The most common way to start is by checking out available jobs. There's a lot of job sites that are built specifically for people seeking employment. You can also go to company websites, where they usually post job listings too. These sites might even have an option to send you an alert when a role matching your search becomes available. Once you find a few that you like, do some research to learn more about the companies and the details about the specific positions you'll be applying for. Then you can update your resume or create a new one. You'll want it to be specific and reflect what each company is looking for, but you can definitely have a master resume that you tweak for each position. It can also help to create a spreadsheet with all of your experiences and accomplishments to help you decide what to include in your resume for each position. If you're using a professional networking site like LinkedIn, you might already have connections who can help you with your job search. Maybe you know someone who can write a referral for you, or knows of a job within their company that would suit you. And even if you don't have any luck with your connections, you can also reach out to employees of the companies you're interested in. They might be able to give you some insight on the best ways to highlight your skills and experience when applying. And it's okay if they don't write back. Keep trying. This is probably a good time to tell you of the most challenging part of a job search: hearing the word no. You'll probably hear it a lot, and that's 100% okay. It's part of everyone's experience, especially when switching career paths. People you reach out to might not be able to help you. Companies you would love to work for might not have any openings. Jobs you applied for might be filled by someone else, and that's all part of the process. The key is to stay focused. Don't get discouraged. And above all else, believe in yourself. Okay, speech over, but don't forget it or I'll be forced to give more speeches. So back to your search. If the company you're applying to is interested, your first point of contact might be a recruiter. A recruiter might also reach out to you based on their own research. They may find your professional profile online and think you're a good match for a position. Speaking of which, that's another reason to keep building and refreshing your online profile. Recruiters are there to make sure you're a legitimate candidate for the job posted in the description. So when you talk with the recruiter, whether on the phone, online, or in person, be professional and personable. It's natural to feel nervous here, so it can help to refer back to your resume to wow them with your knowledge of the data analytics industry. And remember, recruiters are also looking for someone, and they're hoping it'll be you. Here's another tip. Using technical terms like SQL and clean data will show recruiters that you know what you're doing. Recruiters probably won't go into too much detail about the ins and outs of the job, but they want to see that you know what you're talking about. They might also give you prep materials or other recommendations. Take advantage of these because recruiters want you to do well. Next up is usually the hiring manager. This is the most important step. The hiring manager's job is to evaluate whether you have the ability to do the work and whether you'd be a good fit for their team. Your job is to convince them that yes, you do, and yes, you would be. A good thing you can do here is use LinkedIn or other professional sites to research the hiring managers or even other analysts who have a similar role to the one you're applying for. The more information you have about the job, the better your chances of actually getting it. You should also use this opportunity to ask lots of questions to help you figure out if the company's a good fit for you. You can do this when you talk to recruiters too. Now, if the hiring manager sees you as a fit, it's very possible you'll have at least one more interview. The point of these interviews is to give your future stakeholders and teammates a chance to decide if you're the best candidate for the position. The next step is the best step. If all goes well, you'll get an official offer. Usually by phone first and maybe followed by an official letter. At this point, feel free to celebrate, call everyone, and celebrate some more. But even if it's your dream job, make sure it's a competitive offer before you sign. Remember, if they reach out to you with an offer, that means they want you as much as you want them. If you're interviewing at other places, you can leverage this to figure out if negotiating for a more competitive offer is possible. You should also research salaries, benefits, vacation time, and any other factors that are important to you for similar jobs. If you can show specific research like company X gives Y amount more for the same role, there's usually some room to negotiate your salary, vacation days, or something else. Keep in mind, you'll need to find a balance between what you want, what they want to give you, and what's fair. So know your own worth, but also understand that the company hiring you has already placed a certain value on your role. Okay, let's say that everything works out, and you're happy with the negotiated deal and excited to join your new team. Even then, hit pause and give yourself at least 2 weeks before you officially start. Why? Well, if you're already employed somewhere else during your job search, it's customary and polite to give at least a 2-week notice at your old job before starting at the new one. Plus, it's good to give yourself a break before starting your exciting new adventure. You've earned it. By now, you should have a pretty good idea of what to expect when you start your data analyst job search. Coming up, we'll talk more about building your resume. See you in the next video. Great, you're back. When you take a picture, you usually try to capture lots of different things in one image. Maybe you're taking a picture of the sunset and want to capture the clouds, the tree line, and the mountains. Basically, you want a snapshot of that entire moment. You can think of building your resume in the same way. You want your resume to be a snapshot of all that you've done both in school and professionally. In this video, we'll go through the process of building a resume, which you'll be able to add your own details to. Keep in mind this is a snapshot. So when managers and recruiters look at what you've included in your resume, they should be able to tell right away what you can offer their company. The key here is to be brief. Try to keep everything in one page and each description to just a few bullet points. 2 to 4 bullet points is enough, but remember to keep your bullet points concise. Sticking to one page will help you stay focused on the details that best reflect who you are or who you want to be professionally. One page might also be all that hiring managers and recruiters have time to look at. They're busy people, so you want to get their attention with your resume as quickly as possible. Now let's talk about actually building your resume. This is where templates come in. They're a great way to build a brand new resume or reformat one you already have. Programs like Microsoft Word or Google Docs, and even some job search websites, all have templates you can use. A template has placeholders for the information you'll need to enter and its own design elements to make your resume look inviting. You'll have a chance to explore this option a little later. For now, we'll go through the steps you can take to make your resume professional, easy to read, and error-free. If you already have a resume document, you can use these steps to tweak it. Now, there's more than one way to build a resume, but most have contact information at the top of the document. This includes your name, address, phone number, and email address. If you have multiple email addresses or phone numbers, use the ones that are most reliable and sound professional. It's also great if you can use your first and last name in your email address, like janedoe17@email.com. You should also make sure that your contact information matches the details that you've included on professional websites. And while most resumes have contact information in the same place, it's up to you on how you organize that info. A format that focuses more on skills and qualifications and less on work history is great for people who have gaps in their work history. It's also good for those who are just starting out their career or making a career change. And that might be you. If you do want to highlight your work history, feel free to include details of your work experience, starting with your most recent job. If you have lots of jobs that are related to a new position you're applying for, this format makes sense. If you're editing a resume you already have, you can keep it in the same format and adjust the details. If you're starting a new one or building a resume for the first time, choose the format that makes the most sense for you. There's lots of resume resources online. You should browse through a bunch of different resumes to get an idea of the formats you think works best for you. Once you've decided on your format, you can start adding your details. Some resumes begin with the summary, but this is optional. A summary can be helpful if you have experience that is not traditional for a data analyst, or if you're making a career transition. If you decide to include a summary, keep it to 1 or 2 sentences that highlight your strengths and how you can help the company you're applying to. You'll also want to make sure your summary includes positive words about yourself, like dedicated and proactive. You can support those words with data like the number of years you've worked or the tools you're experienced in, like SQL and Spreadsheets. A summary might start off with something like hardworking customer service representative with over 5 years of experience. And once you've completed this program and have your certificate, you'll be able to include that too, which could sound like this. Entry-level data analytics professional. Recently completed the Google Data Analytics Professional Certificate. Sounds pretty good, doesn't it? Another option is leaving a placeholder for your summary while you build the rest of your resume, and then writing it after you finish the other sections. This way, you can review the skills and experience you've mentioned and grab 2 or 3 of the highlights to use in your summary. It's also good to note that the summary might change a little as you apply for different jobs. If you're including a work experience section, there's lots of different types of experience you could add. Outside of jobs with other companies, you could also include volunteer positions you've had and any freelance or side work you've done. The key here is the way in which you describe these experiences. Try to describe the work you did in a way that relates to the position you're applying for. Most job descriptions have minimum qualifications or requirements listed. These are the experiences, skills, and education you'll need to be considered for the job. So it's important to clearly state them in your resume. If you're a good match, the next step is checking out preferred qualifications, which lots of job descriptions also include. These aren't required, but every additional qualification you match makes you a more competitive candidate for the role. Including any part of your skills and experience that matches a job description will help your resume rise above the competition. So if a job listing describes a job responsibility as effectively managing data resources, you'll want to have your own description that reflects that responsibility. For example, if you volunteered or worked at a local school or community center, you might say that you effectively manage resources for after-school activities. Later on, you'll learn more ways to make your work history work for you. It's helpful to describe your skills and qualifications in the same way. For example, if a listing talks about organization and partnering with others, try to think about relevant experiences you've had. Maybe you've helped organize the food drive or partnered with someone to start an online business. In your descriptions, you want to highlight the impact you've had in your role, as well as the impact the role had on you. If you helped a business get started or reach new heights, talk about that experience and how you played a part in it. Or if you worked at a store when it first opened, you can say that you helped launch the successful business by ensuring quality customer service. If you use data analytics in any of your jobs, you'll definitely want to include that as well. We'll cover how to add specific data analysis skills a little bit later. One way to do this is to follow a formula in your descriptions. Accomplished X as measured by Y by doing Z. Here's an example of how this might read on a resume. Selected as one of 275 participants nationwide for this 12-month professional development program for high-achieving talent based on leadership potential and academic success. And if you've gained new skills in one of your experiences, be sure to highlight them all and how they helped. This is probably as good a spot as any to bring up data analytics. Even if this program is the first time you really thought about data analytics, now that you're equipped with some knowledge, you'll want to use that to your benefit. So if you've ever managed money, maybe that means you helped a business analyze future earnings, or maybe you created a budget based on your analysis of previous spending. Even if it was for your own or a friend's small business, it's still data that you've analyzed. Now you can reflect on when and how and use it in your resume. After you've added work experience and skills, you should include a section for any education you've completed. And yes, this course absolutely counts. You can add this course as part of your education, and you can also refer to it in your summary and skills sections. Depending on the format of your resume, you might want to add a section for technical skills you've acquired, both in this course and elsewhere. Besides technical skills like SQL, you could also include language proficiencies in this section. Having some ability in a language other than English can only help your job search. So now you have an idea of how to make your resume look professional and appealing. As you move forward, you'll learn even more about how to make your resume shine. By the end, you'll have a resume you can be proud of. Next up, we'll talk about how to make your resume truly unique. See you soon! Great to see you again! Building a strong resume is a great way to find success in your job hunt. You've had the chance to start building your resume, and now we'll take the next step by showing you how to refine your resume for data analytics jobs. Let's get started. For data analysts, one of the most important things your resume should do is show that you're a clear communicator. Companies looking for analysts want to know that the people they hire can do the analysis, but also can explain it to any audience in a clear and direct way. Your first audience as a data analyst will most likely be hiring managers and recruiters. So being direct and coherent in your resume will go a long way with them as well. Let's start with the summary section. While you won't go into too much detail in this section about any of your work experiences, it's a good spot to point out if you're transitioning into a new career role. You might add something like transitioning from a career in the auto industry and seeking a full-time role in the field of data analytics. One strategy you can use in your summary and throughout your resume is PAR. or PAR statements. PAR stands for problem, action, result. This is a great way to help you write clearly and concisely. So instead of saying something like, was responsible for writing 2 blogs a month, you'd say, earned little-known website over 2,000 new clicks through strategic blogging. The website being little known is the problem. The strategic action is the strategic blogging, and the result is the 2,000 new clicks. Adding PAR statements to your job descriptions or skills section can help with the organization and consistency in your resume. They definitely helped me when I changed jobs. Speaking of the skills section, make sure you include any skills and qualifications you've acquired through this course and on your own. You don't need to be super technical, but talking about your experience with spreadsheets, SQL, Tableau, and R, which is a programming language that we'll get to later, will enhance your resume and your chances of getting a job. So if you're listing qualifications or skills, you might include a spot for programming languages and then list SQL and R, which are both a part of the Google Data Analytics certificate. You might even add in the top functions, packages, or formulas that you're comfortable with in each. It also makes sense to include skills you've acquired in spreadsheets like pivot tables. Pivot tables, SQL, R, and lots of other terms we covered here might get you noticed by hiring managers and recruiters. But you definitely want your resume to accurately represent your skills and abilities. So only add these skills after you've completed the certificate. Once you start applying the ideas we talked about here to your resume, you'll be well on your way to setting yourself apart from other candidates. And after you've completed your final course, you'll have the opportunity to complete a case study and link it on your resume. This will be a great opportunity to show recruiters and hiring managers the skills you've learned while earning your certificate. Before you know it, you'll have a pretty great resume that you can update quickly whenever you're searching for a data analyst job. Nothing wrong with that. Up next, we'll talk more about adding experience to your resume. Bye for now.
Hello, my name is Joseph. I'm a people analyst at Google. As a people analyst, my job is to work with executives and HR business partners to use data to make informed people decisions. Inclusion is very essential to the work that we do. As you know, sometimes you can tell a story with data and have your own bias in it. So for us in this field that is very sensitive, it requires that we have a diverse set of people who have different backgrounds to have this lens of data to it. So being a Black professional, I can better tell a story about people of color that is a lot more personal to me. Being an analyst, it requires me to take data and tell a story with it. On a personal standpoint, I'm very passionate about this space of increasing representation in the tech industry. For example, outside of work, I run a nonprofit called Sankofa Tech, and our whole goal is essentially to help develop the next generation of Black engineers who can essentially be in this field and represent our experience using data as a foundation and also technology as the powering moving factor going forward. And it's critical that we have more Black people in the technology sector. As you all know, the next 10, 20 years, AI and machine learning will be like just speaking English in this country or even the entire world. So the more we can have more Black people in this field, the more we can represent it in the products that are being built, and the more that our experiences are being influenced in every single product that these companies do build. So definitely critical that we have more Black engineers, we have more Black data scientists to do the analysis, and also just Black data analysts to help tell a story that's more inclusive of our experience as well. So it's definitely essential that we do have people from different backgrounds, color, creed, to really understand data and have the lens to it and tell the story and make it very personal to our audience.
Welcome back. Everyone out there has their own personal work history. We all started somewhere, whether part-time or full-time. What matters for your resume is how you present the work you've done. In this video, we'll hone in on work history and how you can translate yours effectively for your data analyst resume. If you don't have a specific section for work history in your resume, that's okay. You can use the same basic ideas to adjust your skills and qualifications section. The good news is that you already have a lot of the skills that recruiters and hiring agents look for when they hire data analysts. You've probably used lots of them in previous jobs. We call these transferable skills. Transferable skills are skills and qualities that can transfer from one job or industry to another. So think about all the positions you've held: associate, owner, team member, manager, and how they might be used as a data analyst. Let's start with the big one that we talked about before: communication. When job descriptions say they want strong communication skills for a data analyst, it usually means they want someone who can speak about what they do to people who aren't as technical or analytical. If someone who's not familiar with data analytics can't understand what you're talking about when you try to explain it to them, your communication skills are usually good to go. You've probably had to communicate in other jobs you've had, whether with employees, customers or clients, team members, or managers. You might have had to give presentations too, whether formal or informal. In your work history section, you can highlight how your effective communication skills have helped you. You can also refer to specific presentations you've made and the outcomes of those presentations. And you can even include the audience for your presentations, especially if you presented to large groups or people in senior positions. After listing job details like the place and length of employment, you might add something like effectively implemented and communicated daily workflow to fellow team members, resulting in an increase in productivity. Here you change the details based on the work you did. Since you'll be working in the world of data, including any quantitative data would be ideal. For example, the increase in productivity might have been a 15% increase. As long as you have a way to back up your data, hopefully with more data, then you can put it in your resume. This example brings us to the next transferable skill. Data analysts are problem solvers. When problems arise in a database or lines of code, data analysts need to be able to find and troubleshoot the problem. If you have no prior experience working with data, you can still talk about your problem-solving skills. That last example we shared does a great job of showing an ability to problem solve. It's actually written as a PAR, or problem action result statement, which we talked about earlier. So the problem is that the daily workflow procedures were not in place. The action is that you put the procedures into effect and communicated them to your team. And the result is that productivity increased by 15%. This makes it clear that there was a problem and you solved it. We can also use the statement to point out teamwork as an important quality to bring to the data analyst world. While you might have plenty of work to do on your own, it'll always be for the benefit of the team. Team means not only the data team you're a part of, but the whole company as well. So that's a few skills you can add to your work experience and skills and qualifications sections. All of these are known as soft skills. Soft skills are non-technical traits and behaviors that relate to how you work. Being detail-oriented and demonstrating perseverance are two more examples of soft skills that anyone hiring a data analyst will look for. Companies want to know that you will do your analysis carefully and to completion, no matter what setbacks you might face along the way. If you worked at a retail job, you can talk about how your attention to detail helped you find discrepancy while handling a high volume of money. And you could add how you continue to practice customer service at a high level, despite a high turnover rate at the management level. These are just some examples to think about and apply to your work details. Take a moment and think back to your last job, or maybe it's your current job. What soft skills do you use to find success? Are you starting to understand how those are transferable to the world of data analytics? Using PAR statements and focusing on your transferable soft skills can really add to the power of your resume. So now you can keep powering on to the next step to continue learning about the data analytics field and your future job in it. See you in the next video.
Hi, I'm Kate. I'm a senior product analyst at Google. I have always been perhaps an annoyingly curious person. Even as a child, I remember I would take things apart just to see how they worked. I just love seeing how things work together. And I love asking new questions. I love having more information. I think that makes me a more well-rounded person and definitely a better analyst. Every step in my career, including the first step in the Army, I kind of always picked at what I could in terms of trying to self-teach on things like databases and things like data. One of my first forays into data was, I had been deployed, and when I came back, I worked with a personnel office, and we had to do things like track where everybody was and what their pay was and their rank, and if, they were getting awards. And there wasn't a single system to work through in that. And so I used an Access database. It took me forever to learn what a foreign key was and what a primary key was. And I will be totally honest, I did really poorly. I ended up going back to Excel, but it was a really good learning experience. After my time in the Army, I didn't really have a sense of what I wanted to do. I had been doing personnel, but I really did still enjoy the technology piece. And I somehow spun my Army career into logistics and got a job doing logistics for what they call the Roundhouse. It's where they work on the locomotive engines. I did a lot of database maintenance. So when I left the railroad, I went to a welding company where I started out as a logistics person working on trucks and truck parts. But then I was able to transition into kind of a more database, data-focused role. After my time at the welding company, I was kind of ready to try something a lot more technical. I actually ended up working for a small consulting firm that was very boutique-y and did a lot of work with Tableau, where we started to work with companies and taught them how to do data visualization. I did Tableau training for a while. But really, I was there for over 6 years. And through my time there, I did database engineering. I did data engineering. I got to run a team of analysts. I got to teach people how to do consulting. There was a lot of growth for me in that 6-year time period. After that, I decided to come to Google. I get to work with stakeholders on translations throughout the Google world. So if anybody wants to translate something from one language to another, I get to work on the analytics of that. So that means that if you take 500 different languages or 40 different languages, what does it cost? How many words do we translate? What does that translation quality look like? If I look back on my career, I would have told myself 5-10 years ago to focus on something. Don't try to feel too overwhelmed. The important thing to be able to do is to be able to ask the right question and know how to answer it. I have confidence. Confidence is really important because people are coming to me for answers. That's my job, is to think really hard about the questions and give them answers that make them better and make the company better. The fact that I know that I can do this now that I've put that kind of time and effort into it, it's really, really rewarding.
Hello. So if you haven't done a search for a data analyst job yet, give it a try. One thing you might notice is how many variations of data analyst jobs there are. You'll find some that just say data analyst in the job title, and others that include more details like market research analyst and digital data analyst. This variety is a good thing. It means that as a data analyst, you'll have a pretty wide range of job opportunities available. So while you might not be the right fit for every position that's posted, every position that's posted might not be the right fit for you. As you continue moving forward, it's important to keep your own interests in mind. There might be certain topics that we've covered or will cover that you find yourself especially interested in. When you're job hunting, you might want to tailor your search to find jobs that are focused on or include your areas of interest. For example, if a job description lists data cleaning as a job responsibility, and you think that you'd really enjoy that process, you could make that job your top priority. At the same time, think about your other interests. If you have a background in retail or medicine or finance, and have had a good experience with it, you might apply for jobs that match your background. As an added bonus, your experience will look great on your resume. But it's also okay to search for jobs in an area of personal interest where you have no professional experience. If you've always loved cars, check out what positions the auto industry has. If you're fascinated by how utility companies work, hunt for jobs in the energy and utilities industry. Finding a job is great. Finding a job you love is even better. Always keep in mind that data analytics is constantly evolving within lots of different industries. So job titles and hiring needs might also change. But the opportunities, no matter what they are when you're searching, will be there. So now let's preview some of the many kinds of data analyst jobs that are out there. The certificate you earn here will be most applicable to junior or associate data analyst positions. But that doesn't mean you have to limit your job search to only postings for junior or associate analysts. Job titles come in all shapes and sizes. New analysts work in a wide range of industries. Healthcare analysts gather and interpret data from sources like electronic health records and patient surveys. Their work helps organizations improve the quality of their care. Healthcare analysts might also look for ways to lower the cost of care and improve patient experience. Data analysts in marketing complete quantitative and qualitative market analysis. They identify important statistics and interpret and present their findings to help stakeholders understand the data behind their marketing strategies. Business intelligence analysts help companies use data they've collected to increase their efficiency and maximize their profits. These analysts usually work with large amounts of data to identify trends and generate business insights. Financial analysts also work with lots of data. Really, all analysts do. But financial analysts use the data to identify and potentially recommend business and investment opportunities. If you're a junior analyst in this field, you'll probably start off doing a lot of data gathering and financial modeling as well as spreadsheet maintenance. This is just a small taste of the types of data analyst jobs out there. Each type we've covered can branch out into other industries as well. For example, business intelligence analysts can work in healthcare, government, e-commerce, and more. It's exciting to think about the possibilities. There's more work for you to do, of course, but there's nothing wrong with looking ahead. And when you get to that place you're looking ahead to, you'll be able to take charge and find the best job for you. For the time being, we'll keep exploring your resume. See you soon. Congrats! You've made it to the end of this course. That means it's time for your next course challenge. We've covered data integrity and how to test your data to ensure that integrity, how to clean dirty data in both a spreadsheet and SQL, and how to verify and report your cleaning results. So go ahead and show off what you learned. You can do it. Great job on finishing this course. You've covered a lot of ground already and learned so much. There's only one thing left to do. Keep going. But if you ever need to check back on what you've learned, these videos will still be available to you. Right now, I'm excited for you to meet your instructor for the next course, Ayana. She's ready to guide you through the next part of the program as you continue your journey to becoming a data analyst. You've learned how to prepare and process data, and in the next course, Ayana will show you how to analyze it. We'll explore how to make sense of all the data you've collected and cleaned, and you'll learn how to ask the right questions and use data to find answers. We'll also show you how to organize and format the data once again, so it's completely ready for analysis. We'll talk about aggregation and joins, two processes that allow you to gather all the data you need and summarize it for your stakeholders. Both spreadsheets and SQL will make an appearance too. We'll give you some more practice with using them for calculations, and we'll explain how temporary tables in SQL work. Awesome job so far, and best of luck on what's next.